Hello friends, welcome to our course about cloud computing and modern network. Cloud computing has become an essential platform for modern businesses, so everyone wants to know and learn more about cloud computing. Organizations moving their applications on cloud and designing the new IT architecture with cloud in mind. But for beginners, there are lots of confusion about cloud computing, like what is infrastructure as a service, platform as a service, software as a service, what is private cloud, public cloud, and hybrid cloud, and why organizations are moving to cloud when they already invested a huge amount of money in their current infrastructure, and how this overall cloud solution work. There are other emerging technologies also like SDN and SD-WAN, which is now deployed with cloud computing. We will talk about practical aspect of all these technologies and will understand how these different components fit together in cloud computing. We will talk about infrastructure as a code tool that are very common to deploy the cloud infrastructure in modern network. This course will be a foundation stone for you if you want to learn how cloud works with SD-WAN technology and how cloud resources are provisioned using infrastructure as a code tools. This course will also help you to clear the AWS certification exam, which adds value for both technical and non-technical resources in current digital world. I'll try to make this course as practical as possible so you can relate the topics to your real-time environment and get the maximum benefits of learning. So let's get started. Let's start from basic and understand what is cloud. Cloud is a network of data centers. These data centers are owned and managed by third-party organizations like Amazon, Google, Oracle. These data centers are built with thousands of servers, storage, and networking devices with very high processing powers. These data centers use the virtualization technology to create and assign the resources to customers. You may be familiar with virtualization technology. Virtualization technology is where you can create the multiple virtual servers on same physical hardware. Consumers like you and me create the resources like servers, storage, networking devices as per our requirement. And virtualization technology used in the data center create the virtual resources on top of physical resources and assigned to different users. The cloud providers charge only for the time the users use the resources. If you created a server for 2 hours on the cloud, you will be charged only for 2 hours. It's not like our traditional data center where you need to purchase and pay the full cost of a server before you use it, even if you need the server only for a week. But in case of cloud, you don't need to purchase the server. You can create the virtual servers as per your requirement for the time you need and pay the charges. Cloud brings lots of benefits for its users. Consumers don't need to make any upfront investment to purchase the infrastructure. You can create the resources on cloud in few minutes, which take months of time with traditional way. The servers and storage capacity can be instantly increased or decreased as per your requirement and business need. Organizations putting that money for their business growth, which they use to invest in purchasing and managing the IT infrastructure in old age. So this is a very high level overview of what is cloud. We will go into more details as we move along in this course. Next, let's talk about cloud computing architecture. Cloud computing architecture is a complex and dynamic system that enables the organizations to design and deliver the secure services to their customers. Cloud computing architecture refers to the software and hardware component that work together to enable the delivery of the cloud services. These components include the physical servers, storage devices, networking infrastructure, and virtualization softwares that make up the cloud infrastructure. The cloud computing architecture shows how all the components required to build a cloud infrastructure are integrated. Cloud architecture divided into two sections. Front-end architecture. Front-end architecture include the user interfaces and applications which are used by the client to access the cloud services. The front end includes the components like local network, web browser, and web applications. Front end allow the user to interact with the back end of the cloud computing. The back end respond to the queries asked by the front end. Backend architecture. Backend architecture in the cloud refers to the hardware and storage that are located in the cloud environment. So let's talk more about front end and back end architecture of the cloud computing. Front end is used by the client to access the cloud applications. Front end contains the client side interfaces and applications that are required to access the cloud computing platform. The front end provides a graphical user interface to end users to access the application. The main front end cloud components are user interfaces, software running on the user's machine, and client devices like laptop or desktop. Front-end architecture includes the user interface that used to send the request to the backend cloud platform to perform any task. Some of the popular user interfaces are web browsers or API. Front-end also include the client devices or local network used by the end user to access the application. The front-end also include the softwares that runs on the user's machine, like client-side applications or web browser. So the front-end part is used by the client to access the cloud services.
Like you open a web browser on your laptop, desktop, or mobile phone to access your cloud hosted application. In this case, web browser on your laptop, desktop, or mobile phone is the front end. The cloud service providers like AWS, Microsoft, or Google manage the backend architecture for cloud computing. The backend usually contains the physical infrastructure and hardware along with security and management software. The cloud provider use the backend architecture to manage the resources that are required to provide the cloud services. In backend architecture, we have application. Application in the cloud computing backend architecture refers to a software or platform accessed by the client. The application takes care of the client request and requirement. Service. Service is an important component of a cloud computing backend architecture. The service handles every task that runs on the cloud. The service component manages which type of service you can access. It may be software as a service, platform as a service, and infrastructure as a service. Storage. Storage in cloud is where your application's data is stored. It provides a large amount of storage capacity to store and manage the data in the cloud. Management layer coordinates between the front end and back end architecture in cloud computing system and oversees like application, administration, and security of the cloud. Security in cloud is necessary in order to protect the assets and data of the business. Security in the backend means protecting the cloud system and data from the unauthorized access. You open a web browser on your laptop, desktop, or phone to access your cloud hosted application via internet. The web browser or your laptop desktop is the front end, and the server where your application is actually hosted is the backend. Overall, cloud computing backend architecture is designed to provide the infrastructure and services to support the delivery of the cloud application. I hope you would have get some basic clarity of the cloud computing architecture.
In this module, we will discuss about cloud computing models. Cloud is very flexible and based on your business requirement, you can deploy and use the cloud in your organization. Some organizations need the full control on the infrastructure created in the cloud. Some organizations don't want to manage their infrastructure. Some wants to build their custom applications. Some wants to use the applications created by cloud providers or third-party organizations. So based on type of deployment, flexibility, management, and control on the cloud, cloud computing is divided into two types of operating model: deployment model and service model. Deployment model is how you deploy and implement the cloud in your organization. It can be private cloud, public cloud, hybrid cloud, or multi-cloud. Service model define the level of access and the management control on the cloud resources, and it can be infrastructure as a service, platform as a service, and software as a service. We will talk about both deployment model and service model in more details in a moment. So let's talk about the cloud deployment model. Cloud deployment model is how you deploy or implement the cloud in your organization. Based on network architecture, the cloud deployment models are further divided into different types like private cloud, public cloud, hybrid cloud, community cloud, and multi-cloud. Organizations are using these cloud computing model based on their business needs and requirement. Each model solves a specific set of problem and serve the different purpose. We will talk about these deployment models in detail in just a moment. Let's talk about private cloud. Private cloud is a dedicated environment for one user or customer. You don't share the hardware with any other users in private cloud. All the hardware is yours and you have full control on it. You can consider the current data center of your organization as your private cloud because all infrastructure in your data center is managed by you or your organization, and that infrastructure is not shared with other. You can host your private cloud on-prem or in cloud providers environment. There are multiple providers like AWS, Azure, VMware where you can host your private cloud. Private cloud can't be accessed from the internet. Only approved users of your organization can access these resources via secure private network. Private cloud has higher initial cost and user is responsible to manage the IT and hardware infrastructure. Organizations use the private cloud to keep their data strictly confidential within their environment. And it is also used with legacy system that cannot be accessed or integrated with public cloud. Private cloud brings lots of benefits for its users. Private cloud provide you dedicated and secure infrastructure with end-to-end control. Private cloud is a single tenant architecture and specific to an organization, which means the hardware, storage, and network are dedicated to a single client. It can be integrated with legacy system that cannot be integrated with the public cloud. Private cloud can be hosted on-prem or you can create your own private cloud within cloud provider's environment. Private cloud is preferred for security or compliance requirement. Next, let's talk about public cloud. Public cloud provide a shared platform that is accessible to everyone through an internet connection. Anyone can create their resources in public cloud. Public cloud physical infrastructure is owned and maintained by third-party providers. Public cloud is an alternative approach to traditional data centers. In public cloud, a third party hosts these scalable resources and delivers them to users via internet or a dedicated network connection. Public cloud saves the organization from owning, maintaining, and operating the complex infrastructure. Data stored in public cloud are open for everyone, and anyone can access the applications hosted on the public cloud. Providers have a multi-tenant architecture, which means multiple users run their resources on shared infrastructure and use the same computing resources. The data and workload for each user is logically separated and remain isolated from the data of the other users, which means no one can access the data of each other even if they are using the same physical hardware. Public cloud brings lots of benefits for its users. Minimal investment. Public cloud is a pay per use service. There is no upfront investment, and this makes it a best choice for users that need immediate access to resources with minimum investment. No physical setup required. The entire cloud infrastructure is fully deployed and managed by the cloud service provider, so you don't need to set up any hardware. No management overhead. The cloud infrastructure is managed by a cloud service provider, so there is no management overhead. Scalability. You can scale the infrastructure up or down as per your business requirement and whenever you need. You have the full flexibility to scale the infrastructure up or down as per your business requirements. Next, let's talk about hybrid cloud. Hybrid cloud combines the benefits of both public and private cloud. In a hybrid cloud, some workloads and data are stored in a private cloud while others are stored in a public cloud. The private cloud can be used for sensitive workloads and data that require high level of security, control, and compliance. The public cloud can be used for non-sensitive workloads that require scalability, flexibility, and cost efficiency. Hybrid cloud is used when you want to keep some of the data strictly confidential within your on-prem environment and wants to host few applications on the cloud for public accessibility. This is most common deployment model used in organizations. The organizations moving their data centers from on-prem to cloud uses this deployment model. Some organizations cannot host all their applications on the public cloud because of security concerns or data protection requirement. Hybrid cloud enables you to run both on-prem and cloud applications at the same time. Managing a hybrid cloud is complex. So if you use a hybrid cloud, the cost of managing the architecture could be high compared to private cloud or public cloud. Next, let's talk about the community cloud. A community cloud is a cloud computing environment that is shared by multiple organizations with similar interest, such as government agencies, healthcare providers, or educational institutions. In a community cloud, the participating organizations collaborate to build, operate, and manage the cloud infrastructure. Community cloud can be hosted either on-prem or by third-party cloud service providers. Community clouds are cloud infrastructure that enables the multiple organizations to work together. It provides a shared platform and resources for organizations to work on their business requirements. Community cloud helps you to do the collaborative work on the cloud. These requirements are usually driven by the need of shared data, shared services, or shared industry regulations. Members of a community clouds are organizations that have common business requirements. Community cloud help you to share the resources and infrastructure with multiple organizations. Community cloud is a suitable model for both collaboration and data sharing. This model is operated and managed by community members, third-party vendors, or both. The organizations that share the common business requirement and wants to work together makes the members of the community cloud. Next, let's talk about the multi-cloud. Multi-cloud is a cloud computing strategy that involves multiple cloud providers. In a multi-cloud environment, organizations uses a combination of public cloud, private cloud, and hybrid cloud for their applications. As cloud is growing popular, uses of multi-cloud is becoming normal, and organizations may run the workloads on different cloud platforms such as AWS, Azure, or Google. There are many regions and organizations select a multi-cloud strategy. A multi-cloud deployment helps the organizations to choose the services from different vendors. With multi-cloud models, an organization can choose the services based on number of factors like contract options, flexibility, and payment. Multi-cloud strategy brings a lots of benefits for the organizations. Maximum availability. By using the multiple cloud providers, organizations can ensure that their services and applications are available even if one cloud provider fails, reducing the cost. By using multiple cloud providers, organizations can take advantage of different pricing models and optimize their cloud spending to reduce the cost. Compliance. Organizations can achieve the compliance and regulations that require data to be stored in specific location or require the certain security measures to be implemented. Avoiding the vendor lock-in. By using the multiple cloud providers, organizations can avoid being tied to a single vendor and can choose the best cloud services for each workload. So we talked about different cloud models. You can take the decision what deployment model is suitable for your organization based on your business requirements. The best cloud model for an organization depend on its specific need, requirement, and resources. We discussed about private cloud, public cloud, hybrid cloud, multi-cloud. Private cloud is best suited for organizations that require complete control over their data and infrastructure. It is best for companies with high security requirements such as those in the healthcare, finance, or in the government sector. Public cloud is typically the most cost-effective option and offers the scalability and flexibility and ease of use. It is best suited for organizations with limited IT resources, those who require a flexible and affordable solution. Hybrid cloud is a combination of public and private cloud that enables the organization to take the benefits of both the models. Multi-cloud involves the multiple cloud providers and organizations uses a combination of public, private, and hybrid cloud for their applications. You can select the right cloud computing model based on scalability. You need to check if your user's activity is growing quickly with spikes in demand. Privacy and security. Select a service provider that protect your privacy and security of your sensitive data. Cost. You may decide how many resources you need for your cloud solution. Ease of use. You may select a model which is easy to deploy and use for the organization. Legal or compliance. You need to check whether any specific laws stop you from selecting any specific cloud deployment model. So you need to choose the right cloud deployment model based on your organization strategy and your business requirements. Cloud computing service model defines the different level of access, management, and control on the cloud infrastructure. Let's talk about the service model of cloud computing. You can have the different level of flexibility, control, and management on the cloud resources. And based on this, cloud resources can be divided in three types like software as a service, platform as a service, and infrastructure as a service. This is called service model. Before we talk about service model of cloud computing, let's take a very famous analogy of ordering a pizza to understand the cloud computing service model. Let's say you want to order a pizza, then you have two options. One option is you can order it, and the other option is you can open a store, hire the staff, and cook the pizza for yourself. What will you do? Most likely, you will order the pizza from the pizza store, which is quick and easy way to get it. There are pros and cons of each approach. If you order a pizza from the pizza store, then you don't have any control on quality of ingredients used to prepare the pizza. You just order the pizza, pay for it, and you get it without knowing who is cooking it and what is used to cook the pizza. So based on your business requirement, you may need control on your infrastructure and on your application environment. And the level of control you get on your cloud infrastructure is defined by these service models. Next, let's talk about the software as a service. Software as a service is like ordering a pizza, where you just order what you need and pay for it. You do not have any control on resources and you don't need to manage the infrastructure. The software as a service model delivers the services and allow the multiple users to access it remotely via the internet. Most SaaS applications can be accessed directly from a web browser without any configuration at user's end. The software as a service are managed from a central location and hosted on a remote server. If there are any issues in accessing the software as a service, then vendors who is providing the services manage the issues like outage, maintenance, software upgrade, bug fix, etc. Software as a service is a multi-tenant architecture and easily customizable, which means multiple users run the resources on shared infrastructure and use the same computing resources. The data and workload of each user is logically separated and remain isolated from the data of other users. SaaS is easily customizable and designed to fit any organization's unique requirement without changing the organization's infrastructure. Emails like Hotmail, Gmail are perfect example of software as a service. We use our personal emails like Hotmail, Gmail without any knowledge of who is managing our email accounts and what is the infrastructure where our emails are hosted. As a user, we just use the service when we need it and everything is managed by the service provider. The services will be available for you all the time. The architecture or the infrastructure of the application is completely hidden to you. In a SaaS service model, you just don't need to manage anything. You just pay for the service and use it. Everything is managed and controlled by the service provider. You just need a web browser or API on your machine to access the applications. Next, let's talk about the platform as a service. In some scenarios, you want some control on your application and data. Platform as a service allow you to host the applications on the cloud instead of buying the services from the service provider. It's a leading service model that helps to address the modern business requirement. It's a simple and cost-effective deployment of applications with full control. This model is used when you want to host the applications that should be in your control, but don't want to manage the infrastructure where that application is hosted. The service provider provides you the pre-built platform managed by them to host your application. The application will be in your control, but the infrastructure where the application will be hosted will be managed by the service provider. Platform as a service leverages the virtualization technology to scale up or down the resources as per your requirement. A platform as a service model is perfectly suitable if you want to host new application but don't want to install the hardware or software personally in your place. It is best used for development, testing, and deployment of customized applications. Platform as service brings more value to cloud. It reduces your management overhead and lower the cost. In platform as a service model, you manage your applications and the infrastructure where that application is hosted is managed by the service provider. Next, we have infrastructure as a service. Infrastructure as a service provide you full control on infrastructure. You create your own servers, network resources, storage, choose your operating system. This model provides the same technologies and capabilities as a traditional data center without burden of physically maintaining and managing the infrastructure. Infrastructure as a service is flexible and easy to deploy the resources in the cloud. You can increase the storage or servers as per your requirement. Except the management of physical hardware, you manage and control everything in the infrastructure as a service model. You can purchase the infrastructure as a service based on a consumption model instead of purchasing the hardware. This model enables you to add, delete, or reconfigure the IT infrastructure on demand. In this model, you manage and control up to the operating system. All physical hardware is managed by your service provider. So we talked about infrastructure as a service, platform as a service, and software as a service. You can use any of the cloud service model based on your business requirement. On-site is having all your resources in your full control and manage everything your own, like your private data center. You can use the infrastructure as a service if you need full control on the infrastructure. This model helps the organization to change the hardware and software easily if your business requirements get changed. Platform as a service model is useful for companies developing, running, and managing the application interfaces but don't want to manage the infrastructure. If you develop a service like monitoring service and you want to sell your service to customers, then platform as a service model is more suitable for you as you just need to manage your service. You don't need to manage the infrastructure where that service is hosted. Software as a service helps in delivering the applications that can be widely distributed and accessed. So based on your requirement and business need, you need to choose the right service model for your organization. Next, let's quickly discuss about cloud computing stack. Cloud computing has changed the way of doing the business and how individuals use the technology services. But how does it work? Let's discuss the cloud computing stack that make up the cloud. Cloud computing stack refers to the layers of technology and services that make up the cloud computing infrastructure. It's like a pyramid where each layer is built on top of each other. Cloud computing stack provides a way to build and deploy the applications without investing in physical infrastructure or managing the softwares. By understanding the layers of cloud computing stack, you can better understand how the cloud works. Let's understand the cloud computing stack with a basic example. Let's say you want to create a web application that allow users to store and share photos. We will use the cloud computing stack to build the application. Here is how it might look. Let's start from the bottom of the stack. At the bottom of the stack, you would need the physical infrastructure to run your application. This could include servers, storage, and networking hardware. Instead of buying and maintaining your own physical hardware, you could use a cloud service provider like AWS or Microsoft Azure to provide the physical infrastructure. Cloud service provider manage this physical infrastructure for you. On top of the physical layer, we have a hypervisor which helps you to virtualize the physical infrastructure. Once you have access to the physical infrastructure, you would need to create a virtual servers to run your application. You could use a service like EC2, Microsoft Azure Virtual Machines to create and manage your virtual servers. You can choose your own operating system, storage, and networking components. This layer is generally referred as a infrastructure as a service, as it provides you the virtual infrastructure to host your applications. Once you have your virtual servers in place, you would need to install and configure the softwares that application require. This layer can include things like operating system, database, and middleware. By providing these tools and services, the platform layer makes it easier for developers to create and deploy the applications on the cloud. As a developers, you don't need to create and manage the infrastructure. You just need to build the application and the infrastructure is managed by the cloud service provider. This is generally referred as a platform as a service. Now that your platform is set up, you would need to build your application. This could involve writing code, adding features like text, messaging or payment system, emails. This layer makes it easy to access the application without the need of any change at customer end. This layer is generally referred as a software as a service or a SaaS layer. Finally, at the top of the stack, we have the user. This is where user interact with the cloud. This layer include the interfaces such as web portals, mobile apps, and APIs that allow users to access the services provided by the cloud. So based on level of control and management flexibility,
you can select how you want to host your web application. Let's say if you want the full control on your web application, then you can go for the infrastructure as a service. You can host your own EC2 instance or Azure virtual machine. That EC2 instance or Azure virtual machine will be in your full control. So you can easily create, delete, or scale the EC2 instance or the Azure virtual machine whenever you need. So that's basically the infrastructure as a service. But if you want to use the pre-built platform and you don't want to manage the underlying EC2 or the virtual machine, then you can host your application as a platform as a service model. Cloud computing stack provides a way to build and deploy the complex applications without investing into the physical infrastructure. By using the cloud computing services, you can focus on building your application rather than worrying about managing the underlying technology and infrastructure. Cloud resources are essential components that allow the users to store, manage, and access the data and applications from anywhere in the world. There are multiple methods that can be used to provision and configure the resources in the cloud. Method 1, using cloud service provider. The easiest way to create the cloud resources is by using a cloud service provider such as Amazon Web Service, Microsoft Azure, or Google Cloud Platform. These providers offer a wide range of cloud based services such as storage, computing power, and databases, which can be created and managed through a user friendly web based console. To create a cloud resources using a service provider, you just need to select the resource you need, specify the configuration, and the provider will take care of the rest. This approach is great for those who don't have a lot of technical knowledge or don't want to spend a lot of time managing their resources. Another way to create the cloud resources is by using the infrastructure as a code tool or IAC. IAC allow you to define and manage your cloud resources using code, and it makes it easier to deploy and manage the complex cloud environment. Tools like Terraform, CloudFormation, and Ansible can be used to create, modify, and delete the cloud resources using code. With infrastructure as a code tool, you can define your cloud infrastructure as a code file and version it using source control. It makes it easier to manage the changes and collaborate with the other team members. The infrastructure as a code tool are quite straightforward and declarative. These tools abstract the coding complexities from user and create the resources. You can also create the cloud resources using container technologies such as Docker and Kubernetes. Containers allow you to package the applications and their dependencies into a single portable unit that can be easily deployed on any of the cloud platform. And then Kubernetes can be used as orchestration platform to manage and scale the containerized applications. This approach is great for those who want to create highly scalable and portable applications that can run in any environment. We will use both Cloud Service Provider Web Console and infrastructure as a code tool to create and manage our resources in our lab environment in this course. And then you can easily decide what method is best suited for your environment to create the resources in the cloud. So far in this course, we discussed about basic cloud concepts that you should be aware of before deep dive for the cloud certification. We will talk about AWS cloud certifications and cover the topics for AWS Cloud Practitioner exam. So let's get started. AWS has its customers across the globe, and every customer wants the better performance of their applications. So AWS hosted its infrastructure globally and designed the infrastructure to provide the low latency and high speed access to AWS services for its customers. AWS has wide range of services to offer to its customers, and its cloud concepts are broadly categorized into four different categories. AWS global infrastructure that include physical infrastructures like regions, availability zones, local zones as locations. The other broad category is security and compliance that include the security control and compliance certifications. Next, we have architecture on AWS that include best practices for deployment and operations on the AWS cloud. And then AWS services that include compute, storage, database, networking, and other services offered by AWS. So we will talk about each components in detail in this course. So first, let's talk about the AWS global infrastructure. AWS has customers across the globe and every customer wants the better performance of the application. AWS hosted its infrastructure globally to provide the low latency and high speed access of AWS services to its customers. AWS global infrastructure include the multiple components like regions. A region is a geographical area where AWS hosted its physical infrastructure. There are multiple regions and each region consists of multiple availability zones. Availability zones. Within region, we have availability zones and each availability zone contains multiple data centers for high availability. Local zones bring cloud more closer to users and provide the low latency access of AWS services to customers. As locations used to deliver content with better performance to end users and used as a content delivery network. Direct connect locations are physical locations where customer can establish a dedicated connection to AWS to access the cloud resources. So don't worry if you are not aware about any of these components. We will talk about these components in detail and we'll see how you can utilize these core components of AWS global infrastructure to host your applications on the cloud. First, let's talk about the AWS region. Every customer wants to host the application closer to their location for better performance. So AWS has hosted its physical data centers at multiple geographical locations in the world. Regions are those geographical areas where AWS decide to host their physical data centers. So customers can choose a data center close to them to host their applications. AWS has multiple regions and each AWS region can have one or more availability zones. You can host your application in closest AWS region for better performance. The closer is the region, the better is the performance for the users. At the time of this recording, AWS currently has 30 regions globally. AWS keep on adding the new regions on time to time basis. You can always get the updated list of AWS regions and availability zones from the Amazon official website. To get the updated list of AWS regions and availability zone, let's go to the Amazon official website, aws.amazon.com. And if you scroll down the page, at the bottom of the page, you will see the section Global Network of AWS region. And this is the list of the AWS regions where AWS has hosted its region across the globe. There are two color dots, the green one and the red one. The green dot means the AWS region is official and you can host your applications in this region. And the red zone means the AWS region is coming soon and it's not yet ready to host the applications for the users. And if you want to see how many availability zones are hosted in each region, just click on the list view. And here you will see the number of availability zone in each AWS region. So if you are planning to host your applications on AWS cloud, you can always come to aws.amazon.com to confirm the closest AWS region. Next, let's talk about availability zones. Availability zones are physical locations where multiple data centers are hosted. Availability zone exists within AWS region. There are multiple availability zones within a region which are connected to each other with high speed and low latency network. So first, we have AWS regions. Within each AWS region, there are one or more availability zone, and each availability zone has one or more data centers connected to each other with high speed links. The availability zones are designed to provide high level availability for your applications and data. In simple terms, availability zone is a collection of data centers within a region with redundant power, network, and connectivity to enable the high availability of your applications. Meaning, if one data center within a region goes down, the users will still be able to access their application via other data center in the availability zone. It is important to note that each availability zone is associated with a specific AWS region. Availability zone has a clusters of data center within a region with redundant power, networking, and connectivity to enable the high availability of your application. There are currently 96 availability zones globally in 30 regions. Now let's just take a high level look at some regions within India. So if you want to validate the availability zones within region, just hover over the name of the region. You see that in Mumbai region, we have 3 availability zone and 2 local zone. In Hyderabad region, we have 3 availability zones. You can also click on list view and see the region name for which you want to find how many availability zones are there. So we are talking about India. So in India, we have two regions. One is Mumbai region that's launched in 2016. Here we have 3 availability zones and 2 local zones. And in Hyderabad region, we have only 3 availability zones. So we talked about AWS regions and availability zone. So when we plan to host a application on AWS, be it for mobile users, home users, or corporates, we get an option to select the region and availability zone to host the application. Once you host the application, then user can access the application via internet or direct connect based on your application architecture. When one of the data center in availability zone goes down, your application will be accessed via redundant data center. And if in worst case, complete availability zone goes down, you can access your application via redundant availability zone. So when you create a resource in AWS, you get an option to select the region and availability zone within that region to host your resources. For example, you might see something like US West 1A. So let's break it down and understand what it means. So first, you might guess that US in the beginning stands for the United States, and you would be correct. Yeah, this is going to be the area. We then have a sub area within that main area. So in this case, this would be the western side of the US. We then have a number because we might have two different regions or more in a specific area. And this is the case. We have both US West 1, which is Northern California, and US West 2, which is Oregon. But we leave off the latter, that gives us the region name. So when we are talking about a region, we would say US West 1 as a region. But if you want the entire availability zone name, it would include everything from US West all the way to 1A. So we talked about AWS availability zone. Let's quickly summarize the key points of availability zone. Resiliency. Each AWS availability zone is a physically separate and independent data center with its own power, cooling, and networking infrastructure. Redundancy. AWS deploys multiple availability zones in a region to ensure high availability and fault tolerance of your application. In general, there are at least 2 and up to 6 availability zones per region. High availability. AWS availability zone within a region are interconnected with high-speed, low-latency networks to enable the data replication and communication between them. AWS availability zone are designed to provide high availability, and AWS guarantees at least 99.99% availability of application. Deployment. AWS recommends to design your application to be highly available across multiple availability zones to ensure maximum uptime and fault tolerance. You can launch the resources such as EC2 instance, RDS database, and Elastic Load Balancer in one or more availability zone to achieve the high availability and fault tolerance of your application. The cost of deploying the resources across multiple availability zones may be higher than deploying the resource in single availability zone. AWS also provides cross-region replication to help you replicate data between regions. AWS availability zone may have resource limitations such as the number of instances that you can launch or the type of instances that are available in a specific region. So when you are designing your application for AWS, you should consider all these points before hosting your infrastructure on the AWS cloud. Next, let's talk about AWS local zone. You would like to host your infrastructure closer to the end users, and AWS can't build the data centers everywhere, so AWS come up with a solution of local zone. Local zones are like mini data center that places compute, storage, database, and other AWS services closer to end user. You can place resources such as compute and storage at multiple locations closer to the end users. AWS local zones place compute, storage, database, and other AWS services closer to end users. Each local zone is an extension of a AWS region. Local zones provide a high bandwidth and secure connection between local workload and those running in the AWS region. Local zones are essentially a way for AWS to bring the cloud closer to the customers, providing customers with more localized, high performance service with the same level of security and compliance as the main AWS infrastructure. To use the local zone, we need to enable it first, and then we can host our resources in the local zone. Next, let's talk about AWS point of presence. AWS point of presence refers to the physical location where AWS has placed its infrastructure outside of AWS region. The point of presence connected to the AWS regions with high-speed network to provide access to AWS services. Point of presence are spread around the world, which enable the customer to access the services with the lowest possible latency. You can think of AWS point of presence as gateway to the cloud. They allow the customers to access the services such as Amazon EC2, S3, and RDS from any location with the low latency, high throughput, and high availability. Within the overall points of presence, there are two types of infrastructure: as locations and regional cache. Next, let's talk about as locations. AWS as locations are places around the world where AWS has hosted its servers. These servers used to cache and serve the content such as website pages, images, and videos to users as quickly as possible. As locations keep a copy of the content closer to the user so that it can be delivered quickly. So when you use an app or website that is hosted on AWS, the information you need is delivered to you from one of these as locations. These as locations are distributed around the world and are used by services such as Amazon CloudFront or Route 53 to deliver the content with low latency and high performance. And if you are not aware about CloudFront and Route 53, don't worry, we will talk about these in next module. By placing servers in as locations, AWS is able to provide a faster and more reliable experience to users around the world. As locations are especially beneficial for the users located far away from the main location, which can help to improve the performance of websites, streaming services, and other content delivery. For example, if you wanted to create a single page application and you want to be sure that your application could be served as quickly as possible to all the users across the globe, and then let's say you have a user in South Africa or from other part of the world where AWS doesn't have its region. Well, you could make sure that your application could be served from the as location in South Africa via Amazon CloudFront instead of making the users go to wherever the next closest AWS region would be. So AWS as location actually increases the performance of the application for the user. Next, let's talk about the waveland zone. A waveland zone is a logical extension of the region. It's a new type of AWS infrastructure designed to run the workload that require ultra low latency over the mobile network. AWS deploy its infrastructure within communication service providers network, so application traffic from 5G devices can reach the servers running in the wavelength zone without leaving the telecommunication network. Wavelength zone is fully integrated with AWS services such as Lambda, S3, and DynamoDB. Wavelength zone allow the developers to deploy and run the applications on the as of 5G network. Currently, wavelength zones are available in a very limited availability. Wavelength zone is a fully managed and scalable service. The application can then be hosted in wavelength zone that is co-located within a mobile provider's data center. An example of how an application might use the AWS wavelength zone is an online gaming application that is designed for mobile users. Traditionally, this kind of applications would be hosted in a central data center, which would then be accessed by mobile users over the internet. But with AWS wavelength zone, the application can now be hosted in wavelength zone that is co-located within a mobile network provider's data center. That means the mobile user of that application don't need to travel outside of mobile provider's network to access the application. So this gives the ultra low latency access of applications for all mobile users.
You will definitely not like to spend the unlimited amount of money on AWS, so you should have some checks to avoid the spending. In this module, we will discuss about different ways to optimize and reduce the cost when using the AWS services. There are many cost optimization strategies available depending on the specific services and resources. AWS allows the customer to set the budgets and alerts in the AWS cost management tool to monitor and control their spendings on the platform. There are different types of budget that you can create, such as cost budget. AWS cost budget allow you to set a budget for your AWS cost and receive the alerts when your actual cost exceed the budget amount. For example, you plan to spend $100 in a month on AWS services. You will get the alerts when your budget exceed the $100. This saves you from the unexpected AWS service bill. Usage budget. Usage budget allow you to set a budget for the uses of services. Usage budgets are similar to cost budgets, but allow you to set a budget for specific services such as number of S3 requests or the number of EC2 instances running. RI budget or reserved instances budget allow you to set a budget for your uses of reserved instances, which are type of pricing model offered by AWS that allow you to pay lower hourly rate for EC2 instances and RDS database for a 1 or 3 year commitment. Reserved instance budget helps you track your uses and cost of your reserved instances. You can set custom budget that alert you when your cost or usage exceed your budgeted amount. This can help customers stay within their budget and avoid the unexpected charges. If you are a AWS learner, you should definitely set your AWS cost budget to avoid the unexpected bill at the month end. Next, let's talk about the AWS Cost Explorer. If you are utilizing multiple AWS services like EC2 or S3, you would want to know how much you are spending on each service. AWS Cost Explorer is a tool that helps you to view your cost and usage data to analyze and identify the cost optimization opportunities. It helps you to see how much you are spending on each service and what are the possibilities to save the money. It also provides cost and usage data for different levels of granularity, such as by service, by instance, or by tag, that allow you to drill down into specific area of your AWS uses and cost. Cost Explorer can be used for budgeting and cost forecasting for the next 12 months. It also allows you to set budget, forecast the future cost, and see the past cost with the ability to see by time, by service, by resources. You can also use the Cost Explorer to create custom reports that can be used to share your cost and usage data with other members of your organization. AWS Cost Explorer is free to use for all AWS customers and you can access it through AWS Management Console. Next, let's talk about how you can plan for your AWS cost. AWS cost planning is the process of determining how much it will cost to run your application and services on AWS. This includes forecasting the future cost, identifying the cost optimization opportunities, and creating a budget for your AWS uses. Now, there are some tools that can be used to plan your AWS future cost. AWS Pricing Calculator. Pricing Calculator is a tool that allows you to estimate the cost of running the various AWS services. You can use the calculator to estimate the cost for a variety of scenarios, such as running the specific number of EC2 instances for a certain period of time, storing a certain amount of data in S3, or delivering a certain amount of data through CloudFront. The calculator allows you to compare the cost for different types of instances, storage options, and other service configurations, such as different regions and data transfer options. AWS Migration Hub.
AWS Migration Hub is a service provided by AWS that allow you to track and manage your applications migration on the AWS cloud. It allows you to track the progress of your migration using a dashboard and provides the detailed information. AWS Migration Hub can be used to migrate a wide range of applications, including on-prem, virtualized, cloud-based workload, as well as database and storage. The AWS Pricing Calculator is a web-based tool provided by AWS that allows the customer to estimate the cost associated with various AWS services. This allows the customer to add their specific resource requirement and generate the detailed cost estimate for their desired configuration. You can estimate the cost for a workload on the cloud using the calculator. For example, if you are looking to launch a website for your company and you believe you are going to need 10 web servers, two different database servers, well, you can enter all of these factors into the pricing calculator and determine how much it would cost and share the results with other. You can even look at different ways to build it and then compare the cost between the different approaches. Pricing calculator is very useful for cost optimization and planning. Next, let's talk about AWS resource tag. Tags are key value pairs that can be added to AWS resources in order to track and manage those resources. These are just metadata that can be assigned to the AWS resources. AWS tags include a name and an optional value. So let's say, for example, if we have a website that we are launching and we have 5 web servers, well, we could go in and just put the web server as a tag on each of those servers. And then when we want to explore our cost, we could say, okay, how much we are spending on everything that has a tag as web server. But another common use case here is to include the department, environment, or project. So let's say that you have some internal application that HR is using. What you can do is you could set a name of department and then you could enter in an optional value of HR. Or we could break it down by environment. Many times when we build the application in the cloud, we will have a testing environment and a production environment. So we could create a tag with the name of environment and the value could be either production or testing. Now with this, you can utilize your cost allocation report to see your cost grouped by active tags. Tags can be enabled within the Cost Explorer. Next, let's talk about AWS organization. AWS organizations allow you to create a centralized structure for multiple AWS accounts where you can view, manage, monitor, and control the cost. This allows the organizations to manage multiple accounts under a single master account. So instead of doing what we mentioned earlier with department and having HR, for example, as one of the department, we can actually create a completely separate AWS account for HR under a master account. It provides ability to organizations with the ability to leverage the consolidated billing for all accounts. So this means that even if you have 100 different AWS account using AWS organizations under a single master account, you only get one bill. And we can see within that bill a breakdown of our cost by account. It enables the organization to centralize logging and security standard across the accounts. We can also go into the cost explorer in the master account at a high level and we can see the breakdown of our cost within each account. So we talked about tools provided by AWS to organize and optimize the cost in AWS environment. Let's quickly summarize the function of each tool. AWS budget allow you to set budget that prevent you to spend the unlimited amount of money on the AWS resources. Resource tag allow you to tag the resources and filter the resources for cost optimization and group the different resources. Cost Explorer helps you to see how much you are spending on each service in AWS. Cost planning helps you to see how much would it cost to run the certain AWS services. AWS organization allow you to have centralized security logging and cost management. So these are the different tools provided by the AWS for the cost optimization. So we should be aware about the uses and function of these tools. Supporting AWS infrastructure involves a range of activities. It requires ongoing monitoring, maintenance, and management to ensure that your environment is running smoothly, securely, and cost effectively. So next, we are going to talk about how you support your AWS infrastructure once you transition some of your applications to the cloud. So next, let's talk about the tools that AWS provide to support your infrastructure. And we are really talking about the AWS support, which is the service that enable you to file the support request with AWS resources. Within AWS support, there are two additional services that are also made available to you. The first is personal health dashboard and second is trusted advisor. So let's take a look at each of these services. Let's talk about the AWS trusted advisor. AWS Trusted Advisor helps you to optimize your use of AWS services. It's an automated tool to check your AWS uses against best practices. It checks your AWS infrastructure for potential issues and provide the recommendations for the improvement. It examines your security, performance, and cost efficiency settings and alerts you if there are any issues or if you could be saving some money. It also provides the actionable guidance on how to resolve the issues and improve your overall health of the AWS infrastructure. It's like having a personal advisor to check your AWS environment and give you the tips to improve it. All AWS customers get access to the 7 core checks of the trusted advisor, and it can be accessed from the AWS Management Console. Next, let's talk about AWS Personal Health Dashboard. Personal Health Dashboard is a web based service provided by AWS that helps AWS customers to improve their infrastructure health and performance. It provides real time alerts and guidance to help customers optimize their AWS resources, increase availability, and reduce the downtime. The Personal Health Dashboard monitors the health of the AWS services and resources used by the customer. It notifies about any potential issues such as service disruption or resource degradation and provide the recommendations to customers to resolve these issues quickly. Customers can use the AWS Personal Health Dashboard to view their account's overall health status, review the notifications and alerts, and manage their AWS resources. They can also customize the dashboard setting and filters to receive the alerts for specific services or resources. The AWS Personal Health Dashboard is free to use and available to all customers. Customers can access the dashboard through AWS Management Console, AWS CLI, or AWS SDK. Next, let's talk about the different support plans available to support the AWS infrastructure. There are different AWS support plan tiers available. Basic support. Basic support provide access to AWS Trusted Advisor and AWS documentations. Developer support provide 24/7 access to AWS support and access to the AWS Trusted Advisor. Business support provide 24/7 access to AWS support, AWS Trusted Advisor, and account management features. Enterprise support provide 24/7 access to AWS support, AWS Trusted Advisor, account management features, and technical account manager. So we need to understand the difference between the different support plan tiers available, and it really falls into 4 key areas. The first is communication method, which means how you can communicate with the AWS support engineers. Response time, which means how early you expect AWS to respond on your queries. And then we have the level of support, which means up to what level of support you want AWS to offer. And then we have the cost. So based on the response time, level of support, AWS charge the cost of the support services. So let's talk about the different types of support services offered by the AWS in more detail. First, we have the AWS Basic Support. AWS Basic Support is a cost-effective support plan and is available for all AWS customers and users who need assistance with AWS core services. The basic support include access to AWS documentations, white papers, and FAQs, as well as the ability to open and manage the support case with AWS. Basic support plan include a monthly usage report, access to AWS Trusted Advisor, and the ability to use the AWS Personal Health Dashboard to view the operational health of your resources. The cost of basic support is based on the total monthly usage of AWS services, and there is no minimum fee. Next, we have AWS Developer Support. AWS Developer Support is a support plan for developers that provides additional assistance with AWS services, such as the technical guidance and troubleshooting. This plan includes all features of the basic support. This plan is for developers who need more advanced support than what is included with the basic support. With developer support, you have access to technical experts who can help you with the code level issues, and you can also receive guidance on best practices for developing and deploying the applications on the AWS. Additionally, you get access to AWS technical support APIs and the AWS Support Center, which include tools for managing your support cases. The cost of developer support is based on the total monthly usage of the AWS services, and there is a minimum monthly fee. Developer support is limited to one primary contact, so that individual need to be the one who actually file the support request with the AWS. Next, let's talk about the AWS Business Support. AWS Business Support include all features of developer support and provides the full 24/7 technical support for businesses using the AWS services. This plan is designed for organizations that have high volume of users. It includes all features of developer support and full set of trusted advisor checks. With business support, you have 24/7 phone, email, and chat access to support engineers. So you can directly pick up a phone and actually call an engineer. Business support allow you to let all your resources have access to support center and file the support request. With AWS Business Support, you have access to a dedicated technical account manager who can help you with strategic planning, architecture design, and operational best practices. So, if you are in a scenario where you want help in deploying a third party software into AWS, this is the support tier that will help you. AWS Business Support starts at $100 per month and it is tied to your AWS usage. So, with more AWS users, you would end up paying more than just $100 per month. Next, let's talk about the AWS Enterprise Support. This plan includes 24 into 7 access to AWS technical support, a designated technical account manager, and access to online and in person training, as well as other benefits such as architectural guidance, best practices, and access to the AWS Trusted Advisor. It is designated for businesses that require a high level of support and have a critical need for AWS resources and services. Enterprise support starts at $15,000 per month. The cost of AWS enterprise support varies depending on the level of AWS usage. It is based on percentage of the overall AWS usage cost. So in this module, we started off by understanding the tools that are provided by AWS to support the workload in the cloud. And then we reviewed the specific AWS support plan tiers that they provide. We then talked about the AWS Trusted Advisor Check and the Personal Health Dashboard. So I hope you get the basic idea of the AWS support plans available and you can opt the best support plan as per your business requirements. Let's talk about how can we interact with the AWS platform to access the services. There are different approaches to interact with the AWS platform and to access the AWS hosted applications. AWS Management Console. This is a web-based interface that allows you to access and manage the AWS services using a web browser. AWS Command Line Interface. This is a command line tool that allows you to interact with AWS services using commands. It can be installed on your local machine and configured with your AWS credentials. AWS SDK. These are software development kits that allow you to interact with AWS services from your application code. AWS provides SDK for several programming languages such as Java, .NET, Python, Ruby, and more. AWS Application Programming Interfaces. AWS services expose the APIs that can be accessed over the internet using standard protocols such as HTTP and HTTPS. Developers can use these APIs to programmatically interact with the AWS services. AWS partner and third party tools. There are many third party tools and services available that integrate with the AWS and provides additional functionalities. Some examples include monitoring and management tools, analytic tools, and security tools. Now, let's talk about when you would use one of these approaches versus another. So, first of all, the console is a great method for accessing the AWS services very first time. So, if you want to access a service for the first time, if you want to spin up a virtual server, or maybe you want to test out a new service that AWS just announced, the console is a great way to do this. But for the repeated task, you might want to use either CLI or the SDK. If we require a person to log in into the browser to perform the repeated task, that can be very cumbersome. And if you need to do the repeated task continuously, that becomes a great choice for the automation. And both CLI and SDK can enable that automation. SDK enable the automation of AWS tasks within the custom applications. So if you have a custom application that you are running on the AWS platform and you want to automate the application to interact with the AWS services, the SDK becomes a great choice for that. Now, it's important to note here most of these services and actions can be performed using any of these ways. Now, there are some exceptions to that rule, and we will cover a few of those within this course. But at a high level, just note that for most of the services, you will be able to use either CLI, console, or SDK to perform whatever task you want to perform on those applications. AWS offers a wide range of services to help organizations build and operate their applications and services in the cloud. The core services of AWS can be grouped into several categories. AWS core services can be grouped into several categories, such as compute services. Compute services allow you to run virtual machines, containers, and serverless functions in the cloud. Examples include EC2 instances, AWS Elastic Beanstalk, and AWS Lambda. Storage services. Storage services provide scalable and highly available storage solutions for data and backup. Examples include S3, EBS, and Glacier. Database services provides managed database solutions for storing and managing the data. Examples include relational database services, DynamoDB, and Amazon Redshift. Networking services that provides the network connectivity and security for your cloud resources. Examples include VPC, Route 53, and AWS Direct Connect. Security and identity services that provide security and identity management for your cloud resources. Examples include AWS Identity and Access Management, Amazon Guard Duty, and AWS Certificate Manager. Analytics services that provides tools for analyzing and visualizing the data. Examples include Amazon QuickSight, Redshift, and Amazon Kinesis. Management and governance services that provides tools for managing and governing your cloud resources. Examples include AWS CloudFormation, AWS System Manager, and AWS Organizations. Applications integration, services that provides messaging, workflow, and other integration patterns for connecting and coordinating the distributed applications. Examples include simple queue services, AWS step functions, and Amazon Event Bridge. Developer tool services that helps the developers to build, test, and deploy their applications. Examples include AWS Code Commit, AWS Code Build, and AWS Code Deploy. Let's talk about the compute services first. AWS Compute Services refers to a set of services that allow customers to run virtual machines, containers, and serverless functions in the cloud. These services provides the ability to easily provision, manage, and scale the computing resources to meet the demand of cloud-hosted applications and services. We will review the major categories of the compute services, including network and content delivery, file storage, database, app integration, management, and governance services. So, first, let's talk about the compute services on AWS. At a high level, a compute service is just a service that enables you to leverage the cloud based virtual machines for your workload. Let's say if you need a virtual machine on cloud for your application hosting, compute services helps you to create that virtual machine. There are different compute services such as EC2. Amazon EC2 is a fundamental core service on AWS. EC2 is a scalable and flexible cloud computing services that allow the users to launch the virtual machines with a variety of operating systems, configuration, and storage options. EC2 provides a range of instance types that can be used for a variety of computing needs, from simple web hosting to complex, high performing computing workloads. Elastic Beanstalk. Elastic Beanstalk is a fully managed service that makes it easy to deploy and run the web applications in the cloud. Beanstalk take care of provisioning the necessary infrastructure, capacity planning, and application monitoring, allowing the developers to focus only on writing the codes. AWS Lambda. Lambda is a serverless computing platform that allows the users to run their code without having to manage and provision the infrastructure. With Lambda, users can simply upload their code, specify the compute resource needed, and the platform automatically scale the compute resources as required. Let's talk about EC2 service in more detail. Elastic Compute Cloud or EC2 is a web service provided by AWS that allow the customers to create a virtual machine in the cloud on which customers can run their applications and services. In simple terms, EC2 allow you to rent a virtual server in the cloud and you can customize the EC2 according to your need. You can choose the amount of CPU, memory, storage, and operating system you need and the softwares you want to run on it. You can use the EC2 for any of the purposes like web application hosting, web service endpoint, and running the desktop in the cloud. EC2 instances can be scaled up or down depending on the load, which makes it a cost effective and flexible solution for running your applications and services in the cloud. Scaled up or down means the amount of CPUs, memory, hard disk can be increased or decreased automatically as required. And you can also increase the number of instances based on your application's load and requirement. AWS allow you to stop and start the EC2 instances when you don't need them, and you only pay for what you use. This makes it a cost-effective solution for running your applications and services in the cloud. AWS offers a different types of EC2 instances. The customer may have a different use cases. Some need high memories, some require high processing power, some customer need high graphics. So considering the different use case and requirement, AWS provide a variety of instance types that are optimized for different use cases. The different instance types are grouped into families, and each family is optimized for a different types of workload. The main instance type families are general purpose. These instances are well suited for a wide range of workloads such as web servers, small and medium databases, and development and test environments. Compute optimized. Compute optimized instances are designed to provide high performance computing capabilities for workloads that require significant amount of computational powers such as batch processing, distributed analytics, and high performance computing. Memory optimized. These instances are optimized for memory intensive workloads such as high performance databases, in memory caches, and distributed web scales. Storage optimized. These instances are optimized for high performance storage such as data warehousing, big data analytics, and log processing. GPU instances. These instances are optimized for GPU intensive workloads such as machine learning, high performance computing, and gaming applications. ARM instances. ARM instances are based on the ARM architecture, which is a type of processor architecture that is commonly used in mobile devices and embedded systems. The main benefits of using the ARM instances is that they tend to be more power efficient and less expensive than instances based on other architectures such as x86. This makes them an attractive option for workload that require a large number of low cost, low power instances. So next, we are going to look at some sample EC2 instance types and pricing. The pricing of the EC2 instances depend on instance type and it gets changed over time. The different AWS region may have a different price for the same instance type. We can check the AWS documentations to calculate the pricing of the different instance types. To check the pricing of the EC2 instances, let's go to the aws.amazon.com. And if you go to this website, you can see the section of on-demand plans for Amazon EC2 instances. So here you can validate the cost of the EC2 instances in each region. So we need to select the AWS region and then let's select the region in which you want to launch the EC2 instance. So for example, if you want to launch the instance in US East Northern Virginia region and we want to run the Linux operating system on the EC2 instance, and we need to select the general purpose instance because we want the general purpose instance. Okay, we may select the compute optimized, memory optimized, or storage optimized as per our requirement. I am selecting the general purpose, and we need minimum 4 virtual CPUs in the instance that we are launching. So based on our selected parameters, AWS has shown us the cost of the EC2 instance. So if you see here, this will be the hourly rate of the on-demand instance that we are planning to launch in the US East Northern Virginia region. And as you see, the cost of the EC2 instance is getting increased as the memory size of the EC2 instance is getting increased along with the network performance. And if we change the instance type from general purpose to compute optimized, the pricing again gets changed based on the calculations. So you can easily calculate the hourly price of the EC2 instance that you are going to launch in the specific AWS region based on your selected parameters. And if you scroll down a bit, you can also calculate the data transfer rate of the EC2 instance. It will help you to analyze how much it will cost if you transfer the data from the EC2 instance to the internet. So based on your application requirements, budget and business need, you can select the EC2 instance and you can easily calculate the cost you need to pay to launch that EC2 instance in the specific region. Next, let's talk about the root device type. You always need the image to boot the instance. The root device volume contains that image. EC2 instances can be launched with different root device types. The root device type refers to the storage device that contains the root file system of the instance. The two main types of root device for EC2 instances are instance store. This is a storage that is physically attached to the host computer that an instance is running on. These EC2 instances have their root device stored on the instance itself, which provides faster input output performance. However, data stored on an instance store is not persistent and will be lost when the instance is terminated. Elastic Block Store. Elastic Block Store or EBS, this is a network attached storage service provided by AWS that allow the instances to access the persistent storage. EBS backed instances have their root device stored on the EBS volume, which allows the root file system to be easily backed up. EBS allow the data to persist after the instance is terminated. When creating an EC2 instance, you will have the option to choose the root device type that best fit your requirements. You can choose the EC2 instance root device type depending on the type of applications, workload, and the data durability. It is important to note that some instance type may only be available as one type of the root devices. For example, ARM instances are only available as instance store backed instances. Next, let's talk about the Amazon Machine Image. Amazon provide you pre-configured virtual images that can be used to launch the EC2 instances. It's like a blueprint or template for virtual computer that include configuration, operating system, and data. You can use the AMI to launch a new EC2 instance that already has all the softwares and configurations that you need to run for your application and service. AWS provides many AMIs that can be leveraged to launch the EC2 instances. You can create your own custom AMIs that can be shared across AWS accounts. For example, imagine you want to start a website and you want to use a specific type of softwares to run on it. An AMI has all the necessary software and configuration to run that website. So you can launch an EC2 instance using that AMI and your website will be ready to go. It's like buying a pre-built computer instead of building one from the scratch. You can choose from different types of AMIs that have different operating systems, software, and configurations. It's a way to save time and effort when you want to launch the new instances and also ensure consistency and compliance across your instances. You can also get the commercial AMI from the AWS Marketplace. So if you want to use the AWS Marketplace, you can go and explore the different AMIs that are provided from the commercial vendors. Next, let's talk about the several purchase options of the AWS instances. Elastic Compute Cloud or EC2 instances can be purchased using several different options on demand. These instances allow you to pay for compute capacity by the hour or by the seconds with no long term commitment or upfront payment. This is the most flexible and easiest way to get started with EC2. Reserved instances. These instances provide a significant discount up to 75% compared to on demand instances if you commit to using the instances for 1 or 3 years term. Reserved instances also provide the options to pay upfront or in a monthly installment. Spot instances. These instances allow you to bid on spare Amazon EC2 computing capacity, making it possible to request spare Amazon EC2 instances at a lower price than the on demand price. Dedicated host. These instances provide you with a physical server dedicated for your use that you can launch one or more instances on. This can be useful for regulatory compliance or software licensing requirements. Saving plan. This option allows you to save up to 72% of your compute capacity by committing to a consistent amount of uses for 1 or 3 years term across the AWS services like EC2 and Fargate. It is important to note that purchase options that will work best for you will depend on your specific use case and requirements. It's recommended to review the different options and evaluate the most cost effective options based on your workloads, budget, and compliance requirement. Let's say if you have a website that you need on a permanent basis, to host that website, a reserved instance is a good choice. But if you need a website temporarily just for the testing, on demand instance is a better choice. But if you need a virtual server for batch processing, Spot instance is a better choice. And if you need a dedicated host to host your applications for compliance region, then dedicated host is a better choice. So the instance type you will choose depend on your business requirement, application requirement, and your compliance requirement. Next, let's talk about the on-demand instance. EC2 on-demand instance are virtual machine that allow you to pay for compute capacity per hour or per second basis without any upfront investment. This model is suitable for short-term or unpredictable workloads and offers low cost and flexible EC2 instances without long-term commitment. Users can increase or decrease the compute capacity as needed. You only pay for the instances you actually use, making it a cost-effective option for testing and the development. EC2 on demand instances do not require a long term commitment or reserved instances. It can be easily launched and terminated as needed, making it a flexible option for a variety of use cases. Next, let's talk about the reserved instances. Reserved instances are a way to save money on EC2 instances by committing to use a specific instance type for a certain period of time, 1 or 3 years term. In return, customers receive a lower hourly rate for that service. To use the reserved instances, customers can make a one-time payment or pay on monthly basis. You can also change or cancel your reserved instances at any time, but you will be charged an early termination fee if you cancel before the end of the commitment period. There are different types of reserved instances. Standard reserved instances. Standard reserved instances provide the highest discount and works well for steady workloads, but customers are locked into the instance type for the duration of the commitment period. What that means is if you want to get a bigger instance type, you cannot make that change. You are locked in for that period of time, whether 1 year or 3 years. Convertible reserved instance. Convertible reserved instances allow the customers to convert some of the attributes to a different instance type of equal value, making it a good option for steady workload. Scheduled reserved instances. Scheduled reserved instances are idle for workloads that are predictable but not steady. For example, that during weekdays for a specific period of time, you are going to have a lot of uses and you want to get a reserved instance for that. The scheduled reserved instance type would work well in that case. Compared to on demand instances, AWS reserved instances can provide cost saving up to 75%. They are a cost effective option for customers who have predictable workloads and can commit to using the instances for a certain period of time. So now let's look at the cost model of standard reserved instances. All upfront. With this cost model, customer pay for the entire reserved instance term upfront at the time of the purchase. This option provides the highest level of saving up to 75% compared to on-demand instances, but requires a significant upfront payment. Partial upfront. With this cost model, customer pay a lower upfront fee and the remaining balance is paid in equal monthly installments for the duration of the reserved instance term. This option provides a lower upfront cost and the flexibility to spread the cost over time, but the savings are slightly less compared to the all upfront option. No upfront. With this cost model, customers do not pay any upfront cost. Instead, the customer pays in equal monthly installments for the duration of the reserved instance term. This option provides the lower upfront cost, but the savings are less compared to the all upfront and the partial upfront options. It is important to note that cost model that will work best for you will depend on your specific use case and requirement. It is recommended to review the different cost models and evaluate the most cost effective options based on your budget and financial planning. Also, you can combine the different cost models for different instance types depending on your workloads and budget. Next, let's talk about the AWS EC2 instance saving plan. With EC2 instance saving plans, customer can commit to a consistent amount of uses for 1 or 3 years term across multiple instance families, sizes, and multiple availability zones. In exchange, customer get a significant discount on the hourly rate for the instances. EC2 instance saving plans provide a customer with flexibility to change the size, family, or the number of instances or the region as their needs change over time. This allows the customers to optimize their cost based on the changing usage pattern. Customers can also use the EC2 instance saving plan with on-demand instances and spot instances to optimize the cost and performance of the instances depending on the workloads. EC2 instance saving plans can provide cost saving of up to 72% compared to the on-demand instances, making them a cost-effective option for customers who have steady state or predictable workloads and who can commit to using the instances for a certain period of time. It is important to note that EC2 instance saving plans is different than the reserved instances. With reserved instances, the customer is committing to a specific instance type, size, and availability zone, whereas with the saving plan, the customer commits to a consistent amount of uses. Next, let's talk about the AWS Spot instances. AWS has a huge infrastructure with large pool of computing resources, and not all of them are being used at the same time. AWS wants to increase the utilization of their existing and unused computing infrastructure by providing the instances at lower prices to its customer. AWS Spot instances allow you to bid on spare Amazon EC2 computing capacity and receive it on a discounted price compared to the on-demand prices. Spot instances offer a flexible and scalable solution for handling the unpredictable workloads. The spot instances can provide up to 90% in discount over on-demand pricing. Now, with this, there is a market price for instance types per availability zone, and this is called the spot price. AWS spot instances can be interrupted by Amazon at any time if the spot price exceed the customer's bid price. Now, it's not instant. You do get a 2 minutes prior to the termination. What that means is this will only work for workloads that can start and stop without affecting what you are trying to do. So if that's your case, you can get great saving by using these spot instances. For example, imagine you are running a website that experiences fluctuations in the traffic. During period of the high traffic, you need more computing resources to handle the increased demand. But during the period of the low traffic, you don't need as many resources. One solution to manage this fluctuation in computing resources is to use the AWS spot instances. You could set up a bid price for the desired instance type and specify the maximum prices you are willing to pay. If your bid price is higher than the current spot price, your instance will be allocated. During period of the high traffic, if the spot price exceed your bid price, your instance may be terminated. However, you can set up the EC2 auto scaling group to automatically launch a new spot instance to replace the terminated one, ensuring that your website is remains available to the users. Next, we have the dedicated host option, and this gives you a dedicated physical server in the data center. Now, this is the most expensive option. AWS dedicated host is a physical server with one or more EC2 instances running on it. Dedicated hosts allow you to use your existing per socket, per core, or per VM software licenses, including Windows Server and SQL Server, and can also help you meet the compliance requirement. Dedicated host can be purchased on demand as a reservation or through the saving plans. They are an additional options to the traditional EC2 instances and can be useful for situations where you need to have full control and visibility over the host where your instances are running on. Dedicated host can be useful in a variety of use cases. Some examples are compliance. Organizations with specific regulatory requirements such as HIPAA or PCI DSS may need to ensure that instances are running on a dedicated host in order to meet the compliance requirement. Next, let's talk about the AWS EC2 instance purchase options. There are multiple purchase options. On demand. On demand purchase options pay for the instances by the hour with no long term commitment or upfront payment. This option is best for users who need flexibility and do not want to commit to long term uses or don't want to pay the upfront cost. Reserved instances. Reserved instances purchase the instances at a discounted early rate with 1 or 3 year commitment. This option is best for users who can predict their uses and want to save money over the long period of time. Spot instances. Bid on spare EC2 capacity and only pay the current spot price. which can be significantly lower than on demand or reserved instance prices. This option is best for users who have flexible workload and can tolerate the interruptions. Dedicated host reserves a physical host for your instances and pay for the host and instances separately. This option is best for users who need full control and visibility over the host where the instances are running on. Saving plan. Saving plan pay a discounted rate for EC2 uses by committing to a set amount of uses over 1 or 3 years term. Scheduled reserved instances. Scheduled reserved instances specify the time when you want to launch the instance and pay a lower hourly rate for the instances that are running during that specified time. AWS Database Service provide fully managed, scalable, and secure databases in the cloud, allow the business to store, process, and analyze their data easily and efficiently. With AWS Database Service, users can choose from a variety of databases, including relational, non-relational, and in-memory databases, and pay only for what they use. AWS Database Services are fully managed, taking care of tasks such as backup, software patching, and hardware provisioning, enabling users to focus on their applications and data. AWS also provides a range of tools for monitoring and optimizing the database performance, ensure that users can deliver high quality, reliable services to their customers. So first, let's understand the difference between data, database, storage, and database engine. Data refers to the information. This can include text, numbers, images, and other types of data. Data can be organized into tables, with each table containing rows and columns. Data stored in the database. A database is a collection of data that is stored and managed by a database management system. A database can be a simple collection of data, such as spreadsheet, or a complex system with multiple tables, views, and relationships. Database is used to store, organize, and retrieve the data as needed. Storage refers to the physical or virtual location where the data is stored. In the context of database, storage can refer to the hard drive or solid state drive where the database files are stored, or it can refer to a cloud-based storage solutions like Amazon S3 that can be used to store data in the database. Data storage solutions are usually optimized for storing large amount of data in a highly available, durable, and scalable way, so that data is always available when needed, and the database can be scaled to handle increased traffic. A database engine, also known as storage engine, it is a component of a database management system that is responsible for managing the storage and retrieval of data. The database engine is responsible for managing the physical storage of data on disk and in memory, as well as executing the SQL queries and the transactions. A query language is a programming language used to communicate with a database. SQL, or structured query language, is a common query language used in a relational databases. But other databases like MongoDB, Cassandra, and Redis have their own query languages. These languages are used to insert, update, query, and delete the data in the database, as well as to create and modify the structure of database. In most RDBMS, SQL is used as the primary language to interact with the database engine. SQL commands are used to create, modify, and query the data stored in the database, and the database engine is responsible for interpreting those commands and managing the underlying data storage. In simple terms, you can think of a database as a container that holds the organized data, storage as the physical space where the database is stored, and a database engine as a software that manages the database and provide the tools for interacting with the data. Together, these components work to store, manage, and access the data in a structured and efficient way. AWS offers a wide range of database services, each designed to support different types of workload and use cases. Here are the primary database types available on the AWS. Relational databases. Relational databases are structured databases that store data in tables with predefined relationship between them. AWS offers several relational database services, including Amazon RDS, Amazon Aurora, Amazon Redshift. Non-relational databases. Non-relational databases, also known as NoSQL databases, are non-tabular databases that store data in flexible format. AWS offers several non-relational database services, including Amazon DynamoDB and Amazon DocumentDB. In-memory databases. In-memory databases are databases that store data in RAM instead of a disk, resulting in much faster data retrieval times. AWS offers Amazon Elasticache, or in-memory cache caching service that support the popular open source caching engines such as Redis and Memcache. Graph databases. Graph databases are designed to store and manage the relationship between data points, making them ideal for use cases such as social networks, recommendation engines, and fraud detection. AWS offers Amazon Neptune, a fully managed graph database service that enable users to build and run highly scalable graph applications. Overall, AWS provides a range of database services that cater to diverse business needs, enabling business to choose the right database service for their specific use case. Let's talk about the AWS Relational Database Service or RDS first. RDS leverages the platform as a service approach to run the database. It is important to note that RDS is a fully managed service and it does handle core things like provisioning and patching, backup and recovery of your database. Now, one of the great thing about RDS is that it does support deployments across multiple availability zone and it also support read replicas for some of the platforms. That means you can actually scale out your database. This can help you scale more efficiently within the applications that are leveraging this database. Now, it is important to note that when you launch an RDS instance, it does launch into a VPC or a virtual private cloud. Now, we talked previously about EBS and different volume types. And here within RDS, we have two different volume types that are available to us. First of all, we have general purpose SSD and then we have provisional IOPS SSD drive. AWS offers a variety of relational database services, including Amazon RDS, a managed relational database service that makes it easy to set up, operate, and scale a relational database in the cloud. It supports popular database engines like MySQL, PostgreSQL, MariaDB, Oracle, and Microsoft SQL Server. Amazon Aurora, a fully managed MySQL and PostgreSQL compatible relational database service that deliver high performance and availability. DynamoDB, a fully managed NoSQL database service that supports key value and document data structure. Redshift, a fully managed data warehouse service that enable the fast querying and analysis of data using SQL and your existing business intelligence tools. Elasticache. Elasticache is a fully managed in-memory caching service that provide high performance, scalable, and secure caching solution for web applications. It supports two popular open source in-memory caching engines like Redis and Memcache and allow the users to create and manage the cache clusters easily in the cloud. Data migration service, a service that makes it easy to migrate your on-prem database to the cloud. Now let's talk about the different platforms that are supported within Amazon RDS. A database platform refers to the underlying software and operating system that a database management system runs on. Amazon RDS supports several platform or operating system for running the relational database including MySQL, an open source relational database management system that runs on a various operating systems including Linux and Windows. PostgreSQL, a powerful open source object relational database system that runs on various operating systems including Linux and Windows. MariaDB, a community developed fork of MySQL. It is fully compatible with MySQL and it can be used as a drop-in replacement for it. SQL Server, a Microsoft Windows based operating system for running the SQL Server databases. Aurora, AWS own relational database engine that is fully compatible with both MySQL and PostgreSQL. Microsoft Windows, a Windows operating system for running the Microsoft SQL Server databases. By choosing one of these platforms, user can easily run their preferred relational database on Amazon RDS and take advantage of the service's managed capabilities. Now, you might be wondering if you have a database that's running within your own data center and you want to move that database to cloud, how will you do that? AWS Data Migration Service is a fully managed service provided by AWS that makes it easy to migrate the database from one environment to another. DMS supports a wide variety of database platforms such as Oracle, SQL Server, MySQL, MariaDB, and MongoDB as a source and target. Data migration service enable you to move data into AWS from existing database and support both one-time and continual migration of data. DMS support many popular commercial and open source databases. You only need to pay for the compute leveraged in the migration process. DMS can be used for a variety of migration scenarios, including migrating a database from on-prem to the cloud, or migrating a database from one cloud provider to another, migrating a database from one region to another, or upgrading a database to a new version, creating a replica of a database for testing or disaster recovery process. DMS support to migrate the data between different versions, engine types, or platform. DMS use a variety of techniques to perform migrations such as full load, change data capture, and replication to ensure data consistency and minimal downtime. DMS also provides a additional features such as ongoing replication and data validation to help you manage and monitor your migration. It also provides an option to use the AWS schema conversion tool to automate the conversion of database object and data type to the target database. Next, let's talk about Amazon DynamoDB. DynamoDB is a NoSQL database service that provides a flexible data models, automatic scaling, and high availability with built-in tolerance. It can handle large amount of structured and unstructured data, making it suitable for a wide range of use cases. DynamoDB is a fully managed database service, which means that AWS takes care of underlying infrastructure and database management tasks such as patching, scaling, and backups. Amazon DynamoDB is a fully managed NoSQL database service provided by AWS. It is designed to handle large amount of data with high performance and low latency. DynamoDB is a key value and document database, which means that data is stored in the form of key value pair, with each key representing a unique identifier for an item of data. The value can be of any type of data, such as string, number, or JSON document. DynamoDB provides the ability to store, retrieve, and query large amount of data with low latency. DynamoDB automatically scales the table up and down based on the volumes of requests and automatically distribute the data across multiple servers to ensure that data is always available when needed. DynamoDB offers in-memory cache with DynamoDB Accelerator. DynamoDB Accelerator is a caching service that helps to improve the performance of read-intensive applications that use the Amazon DynamoDB as a backend database by reducing the response time. Some of the key features of DynamoDB database includes automatic scaling. DynamoDB automatically scale the tables up and down based on the volume of request. So you don't have to worry about provisioning or deprovisioning the capacity. Low latency. DynamoDB is designed to provide low latency performance even at scale. High availability. DynamoDB automatically replicate the data across multiple servers to ensure the data is always available when needed. Global tables. DynamoDB allow you to create the global tables that replicate the data across multiple regions for high availability and low latency performance. Streams. DynamoDB streams allow you to capture and process the changes to the data in the real time. Secondary indexes. DynamoDB support the creation of secondary indexes to allow for efficient querying of data in addition to the primary key. DynamoDB is a great choice for use cases such as web and mobile application, gaming, and IoT. It is also a great fit for use cases requiring a high throughput and low latency data access, as well as for use cases that require a flexible data model. DynamoDB may be a bit expensive compared to other NoSQL databases, especially for high write loads. Additionally, it has a limited set of data types and does not support complex data structures like nested arrays or objects. It also has a relatively small maximum item size of 400 KB, which can limit the amount of data that can be stored in a single item. Finally, DynamoDB does not provide built-in support for full text search or graph traversal, which can make it difficult to perform certain types of queries. So next, we have two other managed services that you can leverage on AWS, and those are Amazon Elasticache and Amazon Redshift. Amazon Elasticache is a web service that makes it easy to deploy, operate, and scale an in-memory cache in the cloud. It is fully managed in-memory data store, meaning it can automatically handle tasks such as software patching, setup, configuration, and backup. Elasticache support to open source in-memory caching engines, Memcache and Redis. Both engines can be used to significantly improve the performance of web applications by allowing them to retrieve data from a fast in-memory store rather than relying on slower disk-based databases. Elasticache can be used to cache the data from databases, web services, and other sources, and can be easily integrated with other AWS services such as RDS, DynamoDB, and S3. It provides extremely low latency in terms of response time, and you can include things like scaling and read replica to meet your application's demand. And again, you can do this without having to be able to manage that underlying infrastructure. It handles most common use cases, including things like database layer caching. So if you are working with another database, even something like DynamoDB, and you want to add a cache layer in between your application and the database, Elasticache could help fill that need, and even session storage. So if you are working with a web application that is doing session storage, you can utilize the Elasticache with something like Redis to be able to get quick response or session data. Practical use case of Amazon Elasticache would be to cache the frequently accessed data from a relational database, such as product catalog or user profile information. By using Elasticache, the application can reduce the number of read operations on the database and increase the performance of the application. Next, let's talk about Redshift. Amazon Redshift is a data warehouse service. Data warehouse is a large centralized repository of data that is used to support the business intelligence activities such as reporting, analysis, and decision making. It is designed to handle large volume of data from various sources and organize it in a way that it is optimized for querying and analysis. Redshift is a fast, fully managed petabyte scale data warehouse service that makes it simple and cost effective to analyze all of your data using your existing business intelligence tools. It provides a massively parallel processing architecture that enable you to scale compute and storage independently for flexible pricing options and to accommodate the changing workloads. Redshift supports data loading from various sources including S3, DynamoDB, and Amazon RDS. It also integrates with other AWS services like Amazon EMR and Amazon QuickSight for data processing and visualization. It is a cost-effective service that allow you to pay only for amount of data stored and the number of compute nodes used. And you can start with a smaller cluster and scale up as needed. There are various key functions of Amazon Redshift. Columnar storage. Redshift uses the columnar storage, which store data in a highly compressed and optimized format to improve the query performance and reduce the storage cost. Automatic compression. Redshift automatically compresses the data based on the column data type and the encoding scheme, reducing the amount of storage needed and improving the query performance. Data encryption. Redshift provides end-to-end data encryption, including data at rest and in transit. Workload management. Redshift provides the workload management features such as query the queues and concurrency scaling to manage the large and complex workload and improve the performance. Data partitioning. Redshift automatically partitions the data based on the sort case, which improves the query performance by reducing the amount of data scanned. Backup and recovery. Redshift provides automated backup and point in time recovery to protect against data loss and corruption. When you host your applications on AWS, you need to transfer your data from on prem to AWS. AWS offers various data transfer services. So let's talk about the different data transfer services that are available. AWS Data Transfer Service is a managed service that enables the secure, reliable, and cost-effective transfer of data between AWS services and on-prem data sources. It supports transfer of data in and out of AWS across regions and across accounts. It provides a variety of transfer options, including AWS Direct Connect, AWS Storage Gateway, and AWS Snowball. It offers a centralized management console for tracking and monitoring the data transfer operations. There are few key data transfer options in AWS. Network based transfer. AWS offers a range of network based transfer options, including AWS Direct Connect, AWS VPN, AWS Transit Gateway, and AWS Private Link. Physical data transfer. AWS also offers a physical data transfer solution such as AWS Snowball and AWS Snowmobile for large scale data transfer need. Hybrid solution. AWS also offers the hybrid solution for the data transfer such as AWS Storage Gateway, which enables the business to seamlessly integrate on-prem infrastructure with the AWS cloud. Third-party solutions. AWS also support a wide range of third-party data transfer solutions, enabling the business to choose a solution that best fit for their needs. When you select the best data transfer option from on-prem to cloud, there are certain key considerations for selecting a data transfer solutions that includes like data volume, transfer speed, security, and cost. So based on these parameters, you can select which data transfer option is best for you. Let's talk about data transfer with AWS Snowball. When you need to transfer the large amount of data, you can use the AWS Snowball. AWS Snowball is a physical device designed to help you transfer large amount of data into and out of AWS and available into two models, Snowball and Snowball S, with varying storage capacity and compute capabilities. AWS Snowball provides a secure and efficient way to transfer terabytes or petabytes of data without relying on the internet. AWS Snowball uses the AES 256-bit encryption and tamper-evident seals to secure your data during transit and storage. Let's talk about data transfer option with AWS Snowmobile. AWS Snowmobile is a secure and high capacity data transfer service that uses a long shipping container to transfer exabytes of data to AWS. Snowmobile provides a fast and secure way to transfer large amount of data without relying on the internet or expensive networking hardware. Snowmobile offers an alternative to physically shipping the drives or using AWS Snowball for very large data set. So based on certain parameters like data volume that you need to transfer, cost, and the time you have to transfer the data, you can select the data transfer option that best fit for your business needs. Next, let's talk about S3 Glacier. AWS S3 Glacier is a cloud-based storage service provided by AWS that is designed for long-term data archiving and backup. It provides a low-cost and secure storage for data that does not need to be accessed frequently but must be retained for a long period of time. S3 Glacier is a low cost, secure, and durable cloud storage service designed for data archiving and long term backup. Data stored in S3 Glacier is referred to as an archive and it is stored in Vault. Each archive can be up to 40 terabytes in size. Retrieving data from S3 Glacier can take several hours, but expedited retrieval options are available for higher fees. S3 Glacier supports three retrieval options: standard, expedite, and bulk. Each option has a different retrieval time and cost. S3 Glacier integrate with AWS services such as S3, AWS Backup, AWS Data Pipeline, making it easy to store and retrieve the data as part of your cloud-based infrastructure. S3 Glacier provides compliance with several regulatory requirements such as HIPAA and FINRA, as well as data security features such as encryption and access control. S3 Glacier has tiered pricing model based on the amount of data stored, the number of archive operations performed, and the data retrieval options. This makes it a cost-effective solution for long-term storage of large amount of data. Glacier is a storage class that provides low-cost storage for data that is infrequently accessed and stored for a long period of time, typically months or years. Retrieving data from Glacier can take several hours, but expedited retrieval options are available for a higher fees. Glacier is suitable for data backup, archival, and compliance use cases. Glacier Deep Archive is a storage class that provides the lowest cost storage option for data that is accessed rarely and stored for a long period of time, typically more than 7 years. Retrieving data from Glacier Deep Archive can take up to 12 hours, but it provides the lowest storage cost among all storage classes offered by AWS S3 Glacier. Glacier Deep Archive is suitable for long term data retention, regulatory compliance, and digital preservation use cases. Next, let's talk about Amazon Elastic Block Store. Elastic Block Store is a storage service provided by AWS. Elastic Block Store is designed to be connected to a single EC2 instance that can scale to support petabytes of data and multiple volume types. With EBS, you can create storage volume and attach them to an EC2 instance, which allow you to persist data even after an instance is terminated. EBS provides several different types of volumes, including general purpose volume. These are suitable for wide range of workloads and are a good choice for boot volumes and small to medium sized databases. Provisioned IOPS volumes. These are designed for input output intensive workloads such as large databases. Throughput optimized volume. These are designed for big data and data warehouses workload that require high throughput. Cold volumes. These are designed for infrequent access workload with a lower cost. Magnetic volumes. These are the original EBS volume type and provide the lowest cost per gigabyte of all EBS volume types, but the lowest performance. EBS also provides features such as encryption, snapshot, and the ability to increase the size of a volume, which makes it a useful service for many types of applications and use cases. EBS offers different types of volumes such as general purpose SSD. General purpose SSD is a storage volume type provided by AWS. It is designed to provide balance of performance and cost for broad range of workload. General purpose SSD are based on solid state drive technology, which provides faster performance than traditional magnetic hard drive. They offer a balance of performance, cost, and durability. They are well suited for wide range of workloads, including boot volumes, small to medium sized database, development and test environment, and file systems. Provisioned IOPS SSD. It is designed for high performance input output intensive workload that require a high level of input output operations per second and low latency. Provisioned IOPS SSD are also based on solid state drive technology, which provides faster performance than traditional magnetic hard drive. They are optimized for input output intensive workloads such as high performance databases, big data workload, and transactional system. Throughput optimized is a storage volume type provided by AWS. It is designed for large sequential workload such as big data and data warehousing. Throughput optimized are based on traditional magnetic hard drive technology. They are optimized for large sequential data workload that require a high level of throughput such as big data, data warehousing, and log processing. Cold HDD is a storage volume type which is designed for infrequently accessed workload and provides the lowest cost per GB of storage. Cold HDD are also based on traditional magnetic hard drive technology and are optimized for infrequently accessed data such as backup, disaster recovery, and long-term archival storage. We will talk about these volume types in more detail in the coming slide. Let's talk about EBS General Purpose SSD. EBS General Purpose SSD is a storage volume designed to provide a balance of performance and cost for a broad range of workloads. General Purpose SSD are based on solid state technology which provides faster performance than traditional magnetic hard drive technology. They offer a balance of performance, cost, and durability. They are well suited for a wide range of workloads, including boot volumes, small to medium sized database, development and test environment, and file systems. General purpose SSD provides a baseline performance of 3 IOPS per GB and burst up to 3000 IOPS for extended period of time. They are also designed to deliver the consistent performance with low variability in IOPS performance. Additionally, general purpose SSD have a durability of 99.999% of object per year and the ability to take snapshot of the data, which can be used to create new volumes or to protect the data from accidental deletion or corruption. Next, let's talk about the provisional IOPS SSD. It is designed for high performance input output intensive workload that require a high level of input output operations per second and low latency. Provisioned IOPS SSD are also based on solid state drive technology, which provides faster performance than traditional magnetic hard disk drive technology. They are optimized for input output intensive workloads such as high performance database, big data workload, and transactional system. Provisioned IOPS SSD have a durability of 99.999% of object per year and the ability to take a snapshot of data, which can be used to create the new volumes or to protect the data from accidental deletion or corruption. Provisioned IOPS SSD are more expensive than general purpose SSD and magnetic storage, but they are designed to provide higher input output performance and lower latency for IO intensive workloads. They are good options for users who need a high level of IOPS and low latency for their workloads. Throughput optimized HDD. Throughput optimized HDD are based on traditional magnetic hard disk drive technology. They are optimized for large sequential data workload that require a high level of throughput such as big data, data warehousing, and log processing. Throughput optimized HDD provides a baseline performance of 48 megabytes per TB of provisioned storage and burst capacity of 250 megabytes per second. They are designed to deliver consistent throughput performance. Throughput optimized have a great durability per year and the ability to take the snapshot of the data, which can be used to create new volumes or to protect the data from accidental deletion or corruption. Throughput optimized HDD are less expensive than general purpose SSD and provisioned IOPS SSD, but they are not as fast as the SSD. They are a good option for users who need a high level of throughput for their sequential workload but don't require the high IOPS and low latency of SSD. Cold HDD. EBS Cold HDD is a storage volume type which is designed for infrequently accessed workload and provides the lowest cost per GB of storage. Cold HDD are also based on traditional magnetic hard disk drive technology and are optimized for infrequently accessed data such as backup, digester recovery, and long-term archival storage. Cold HDD provide a baseline performance of 12 megabytes per TB of provisioned storage. Cold HDD have a great durability objects per year and the ability to take the snapshot of the data. Cold HDD are less expensive than other storage volume types such as general purpose SSD, provisioned IOPS SSD, or throughput optimized HDD and magnetic storage. This storage type is a good option for users who actually need to store the infrequently accessed data and want to minimize the storage cost. Next, let's talk about Elastic File System. Elastic File System or EFS is a fully managed NFS file system and it is designed specifically for Linux workload. EFS is similar to EBS and it can scale up to petabyte of data. EFS can store the data across multiple availability zones so you get the durability by default. EFS provides two different storage classes, standard and infrequent access, and it also provides the configurable lifecycle rules to transition the data between different storage classes. Elastic File System is a scalable, managed network file system that provides shared file storage for Amazon EC2 instances and other compute services. It is designed to support a wide range of workloads from simple file sharing to complex data intensive applications. EFS can be accessed concurrently by thousands of Amazon EC2 instances across multiple availability zones within a region, providing high availability and durability. EFS automatically scale up and down in response to changes in the storage need. EFS provide built-in redundancy and replicates the data across multiple availability zones within a single region. EFS integrates with AWS identity and access management for fine-grained access control. EFS provides consistent low latency performance for file operations. EFS is fully managed by AWS and requires no infrastructure setup or maintenance. There are multiple use cases when you can use the EFS file system. EFS file system is commonly used when you want to share the common data to multiple servers. Next, let's talk about Amazon OpsWorks. OpsWorks is a configuration management service that provides managed instances of Chef and Puppet, which are popular automation platform. OpsWorks enables you to manage and automate the deployment and configuration of your applications on AWS. With OpsWorks, You can create the custom stacks that define the resources required by your application and automate the process of deploying, scaling, and monitoring those resources. OpsWorks has a few core components like stack. A stack is a collection of resources that are created and managed together as a single unit. You can use a stack to create, update, or delete a group of resources at once. A stack is created from a set of configuration files that define the resources and their dependencies. A layer represents a set of resources that perform a specific function, such as running web servers, application servers, or databases. Layers can contain EC2 instances, Elastic Load Balancers, and Amazon RDS instances. Instances. An instance is a virtual machine that runs the software for a particular layer. Instances are created and managed by OpsWorks, and you can configure them with custom recipes and scripts. Recipes. A recipe is a set of instructions that configure and deploy software on an instance. Recipes are written in the Chef or Puppet automation language and are used to automate the installation, configuration, and management of your application. An app is a code repository that contains the source code for your application. OpsWorks can pull the code from Git or AWS code commit repositories and deploy it to your instances. The OpsWorks workflow consists of the following steps: creating a stack. Use the AWS Management Console, CLI, or SDK to create a stack. A stack defines the AWS resources that your application requires, such as EC2 instance, load balancers, and RDS instances. Define the layer. Define the layers that your stack will contain, such as web server, application server, and database. Each layer contains one or more instances that run the software for that layer. Add instances. Add instances to each layer in your stack. You can use the OpsWorks to automatically launch the instances, or you can add the existing instances that you have already launched. Deploy the app. Deploy your application code to your instances. OpsWorks can pull the code from Git or AWS code commit repositories and deploy it to your instances. Configure the instances. Configure your instances using custom recipes and scripts. Recipes are used to automate the installation, configuration, and management of your application. Scale your application. Use OpsWorks to scale your application up or down by adding or removing the instances as needed. OpsWorks is actually used to automate the resource provisioning on the AWS environment. There are multiple practical use cases of Amazon OpsWorks that include deploying the web application. You can use to deploy and monitor the web application, including popular web applications frameworks such as Ruby on Rails, Node.js, and PHP. Managing the infrastructure. You can use the OpsWorks to manage the infrastructure resources such as EC2 instances, Elastic Load Balancers, and Amazon RDS. Application deployment. OpsWorks can be used to automate the deployment of the applications, including building and deploying the code, maintaining the dependencies, and configuration servers. Next, let's talk about AWS organizations. AWS organization is a service that allow you to consolidate multiple AWS accounts into an organization that you can centrally manage and govern. It simplifies the management of your AWS resources and enable you to govern your account with fine-grained control. With AWS organization, you can create an organization, invite other AWS accounts to join, and then organize those accounts into hierarchies that you create. AWS organization is a service that allow you to consolidate multiple AWS accounts into an organizational structure, which can be used to apply policies and settings to groups of account. AWS organization allow you to create and manage a hierarchy of account with parent and child accounts. This hierarchy allow you to apply policies and setting at different levels, such as at the organization level or at the individual account level. AWS organization also provide consolidated billing, which allow you to consolidate billing across all accounts in the organization. Here are some of the core components of the AWS organization. Root, the top level container of all the accounts that are part of the organization. The root is created automatically when you create an organization. Organization unit, a container for accounts that you want to group together for management and governance purpose. You can create organization unit to mirror your organizational structure, such as by department, business unit, or location. Account, an AWS account that is part of your organization. Service control policies, SCP or service control policies that you can apply to organizational unit or accounts to manage permissions and access to AWS services and resources. SCPs act as a guardrail to help you enforce policies for your organization. Tag policies, a policy that you can apply to your organization to help enforce tagging compliance across your accounts. Tag policies enable you to standardize tag across accounts and ensure that resources are properly tagged. Here is a simplified workflow of the AWS organization. Create an organization. First, you need to create an organization from the AWS organization console or using the AWS CLI. Invite accounts to join the organization. You can invite the existing AWS accounts to join your organization. Accounts can accept the invitation using the AWS organization console or CLI. Create OU. You can create the organizational unit or OUs to group accounts together and apply the SCPs or tag policies. Apply policies. You can create and apply the SCPs and tag policies to OUs or accounts to govern access to AWS services and resources. Monitor and manage your organization. You can use AWS organizations to monitor your organization's compliance with policies and manage your accounts centrally. Some practical use case of AWS organizations include consolidating the billing and cost management. AWS organization allow you to consolidate the billing across your accounts, making it easier to track and manage the cost. Let's say if you have multiple AWS accounts in your organization, instead of paying the bill of each individual AWS account, you can create the AWS organization and consolidate the billing of all the AWS accounts and pay in one bill. Centralized governance and compliance. AWS organization provide a centralized way to enforce policies and compliance across your accounts, enabling you to ensure consistent security and governance. Simplified management of large scale deployments. If you have a large number of AWS accounts, AWS organization can help you manage and organize them more effectively. Next, we will discuss about AWS Cloud Formation. AWS Cloud Formation is a service offered by AWS that allow you to automate the creation and management of AWS resources. With Cloud Formation, you can create the templates that define your AWS infrastructure as a code and then use those templates to create and manage your resources. Cloud Formation is a service that allow you to model and provision the AWS resources in a declarative way, which means you specify what you want to deploy and not how to deploy it. This allow you to automate the creation, modification and deletion of your infrastructure in a consistent and repeatable way, so you can automate the deployment, configuration and management of the AWS resources. Instead of manually creating and configuring each resource, you can define them in a cloud formation template, which allow you to launch and manage the resources in a single stack. Cloud formation consists of four core components. Templates. Cloud formation templates are JSON or YAML files that describe the AWS resources that you want to create and how they are related. Templates are used to create, update, or delete a stack, which is a collection of resources that are provisioned together. Templates include resources like EC2 instances, load balancers, RDS databases, and many more. You define the resources in templates, and CloudFormation create those resources for you. Stack. CloudFormation stack are a set of AWS resources that are created and managed together. A stack is created from a template and can be updated, deleted, or recreated as needed. Stacks enable you to manage your infrastructure as a code and simplify the resource management. You can also use the CloudFormation stacks for rollback, which means you can revert to a previous version of your infrastructure if there are any issues with the current version. Change set. CloudFormation change set allow you to preview changes to a stack before applying them. This is useful for reviewing the impact of changes, verifying that your infrastructure will be updated as intended, and avoiding the unexpected consequences. A change set includes the difference between the current stack and the proposed changes, such as adding new resources, modify the properties, or deleting the resources. Resources. CloudFormation resources represent the AWS resource that are created and managed by CloudFormation. Resources can be created, modified, or deleted as part of a CloudFormation stack. CloudFormation supports a wide range of AWS resources, including EC2 instances, S3 buckets, IAM users, and many more. CloudFormation workflow consists of the following core steps. Creating a CloudFormation template. First, you need to define the resources that you want to create on the AWS in a template file. Creating a JSON or YAML file that describe the AWS resources you want to create, modify, or delete. You can either write the templates from scratch or use an existing template as a starting point. Uploading the template to AWS. Once you create the template, then you need to upload the template to S3 bucket or use a local file path. Use the AWS Management Console, AWS CLI, or AWS SDK to create a stack from the template. When you create a stack, CloudFormation provisions the resources defined in the template. Update a stack. You can use the AWS Management Console, CLI, or SDK to update an existing stack with changes defined in a new template. CloudFormation applies the changes to the stack resources as needed. You can delete the stack and its associated resources. CloudFormation remove the resources provisioned by the stack. Use CloudFormation change set to preview the changes to a stack before applying them. This allow you to review the changes and ensure that they will have the desired effect on your infrastructure. So this is the workflow of the cloud formation. To use the cloud formation effectively, it is important to understand how to write and work with templates, how to create and manage the stack, how to use the change set, how to interact with the cloud formation resources. You should be familiar with cloud formation best practices such as versioning your templates, testing and validating your templates, and organizing your stacks. Next, let's talk about AWS Control Tower. AWS Control Tower is a managed service provided by AWS that helps organizations set up and govern a multi account AWS environment. It simplifies the process of creating the new accounts, configuring the security and compliance policies, and managing the resources across accounts while maintaining the desired level of security and compliance. AWS Control Tower is a service that builds on top of the AWS organization and provides additional functionality to simplify the management of a multi account AWS environment. AWS Control Tower includes pre configured templates and policies called guardrails that are designed to enforce best practices for security and compliance. It also includes a pre configured landing zone, which provide a baseline environment for deploying workloads in a secure and compliant manner. AWS Control Tower also include a centralized dashboard for monitoring and managing the environment, which provide visibility into compliance and security across all accounts. AWS Control Tower consists of several core components, including landing zone. This is a foundation of the AWS Control Tower environment. It is a pre-configured set of AWS accounts, networking, and security setting that provide a secure and compliant baseline for workloads to be deployed. Guardrails. These are pre configured policies that enforce best practices for security and compliance across accounts in the landing zone. Guardrails can be customized or created from scratch to fit an organization's specific need. Blueprint. These are reusable templates for provisioning and configuring the resources in AWS environment. Blueprints can be created and shared within an organization, providing a consistent and repeatable way to deploy the workloads. Organizational unit. These are logical grouping of AWS accounts within the landing zone. They can be used to apply policies and setting to specific groups of account. The AWS control tower workflow can be broken down into the following steps. Setting up the landing zone. The landing zone is set up using the cloud formation template provided by AWS. This creates the foundational account and resources necessary for the landing zone. Configure guardrails. Guardrails are configured to enforce security and compliance policies across all accounts in the landing zone. These policies can be customized to fit an organization's specific need. Create OUs. OUs are created to group the accounts together based on the business needs. Policies and setting can be applied to OU to ensure consistent governance across accounts. Provision resources. Blueprints are used to provision and configure the resources within account. These resources are deployed in a secure and compliant manner as defined by the guardrails and policies. Monitor and manage. AWS Control Tower provides a centralized dashboard for monitoring and managing the landing zone. This allows the organization to easily monitor compliance and security across all accounts in the environment. Monitor and manage. AWS Control Tower provides a centralized dashboard for monitoring and managing the landing zone. This allows the organizations to easily monitor the compliance and security across all accounts in the environment. AWS Control Tower can be used in organization to ensure that all workloads are deployed according to the best practices. It can be used to ensure that security and compliance policies are enforced across all accounts. AWS Control Tower provide a consistent and repeatable way to deploy the workloads while maintaining a high level of security and compliance. There is no additional charges for using the AWS Control Tower itself, but organizations will incur the charges for the underlying resources used, such as AWS accounts and services. Next, let's talk about AWS Config. AWS Config is a fully managed service that provides you with resource inventory, configuration history, and configuration change notifications to use for security and governance purpose. With AWS Config, you can discover the existing AWS resources, record the configuration for third-party resources, export a complete inventory of your resources with all configuration details, and determine how a resource was configured at any point in time. These capabilities help you in compliance auditing, security analysis, and resource change tracking and in troubleshooting. AWS config makes it easier to track your resource configuration without the need for upfront investment and avoiding the complexity of installing and updating the agents for data collection or maintaining the large databases. AWS config provides a range of features such as simplify the compliance auditing. AWS config provide a centralized view of your resource configurations, making it easier to demonstrate the compliance for the regulatory requirements. Improve the security. AWS config helps you to identify the security vulnerabilities and misconfigurations in your AWS resources. Reduce the risk. By tracking the changes in real time to your resources configurations, AWS config helps you to identify and remediate the issues before they become any problem. Simplify the troubleshooting. With detailed tracking of configuration changes, AWS config make it easier to troubleshoot the operational issues. Config rules are most important tool of AWS config service. AWS config rules enables you to define and evaluate the compliance against custom or predefined rules. You can evaluate the configuration of your devices based on the configuration rules that you have created. AWS provides a library of pre-configured rules for common compliance requirements such as HIPAA, PCI, and CIS AWS Foundation's benchmark. You can also create the custom rules to meet the specific compliance or operational requirements. AWS config integrate with other AWS services such as CloudTrail, CloudFormation, and System Manager. Integration with AWS CloudTrail provides the detailed logging of configuration changes made to your AWS resources. Integration with AWS CloudFormation enable you to automatically evaluate the resource compliance during the deployment. AWS config offers a free tier that include limited functionality. Additional charges apply for more advanced features such as compliance rule evaluation and resource relationship visualizations. Next, let's discuss about AWS CloudTrail. AWS CloudTrail is a powerful service that provides detailed logging of API activities within your AWS account. By using CloudTrail, you can gain insight into the past activities of your AWS resources, detect and respond to security incidents, demonstrate compliance, troubleshoot operational issues, and monitor the user activities. AWS CloudTrail enables you to log, continuously monitor, and retain the account activities. This is useful for auditing and compliance purposes as well as for the troubleshooting. CloudTrail can be used for security, compliance, and operational auditing purpose. CloudTrail capture the API activities from all AWS services that support AWS CloudTrail, including S3, EC2 instances, AWS Lambda, and many other AWS services. When an API is called, CloudTrail record the identity of the caller, the time of the call, the source IP address of the caller, and the request parameters like who made an API call to the AWS resources, what was the source IP address of the API call, what did the API call do, when did the API call occur, and what was the response to the API call. This information is stored in a JSON format log file in an Amazon S3 bucket, and that can be used for the auditing purpose later. CloudTrail is easy to set up and use. You can enable the CloudTrail for your AWS account with just a few clicks in AWS Management Console. Once enabled, CloudTrail logs all supported API activities in your AWS account. And you can use AWS tools and services to analyze and visualize the log data. CloudTrail can be used for a variety of use cases such as security analysis. Detect and respond to security incidents by analyzing the CloudTrail logs for suspicious activities. Compliance auditing. Use CloudTrail logs to demonstrate the compliance with regulatory requirements. Troubleshooting. You can use the CloudTrail logs to investigate the operational issues such as change made to the AWS resources. Governance. Use CloudTrail logs to monitor the user activities and enforce the access controls. CloudTrail brings lots of benefits in managing the AWS hosted resources. With the help of the CloudTrail, you can gain insight into the past activities of your AWS resources. You can easily detect and respond to the security incidents. You can demonstrate your compliance, help you to easily troubleshoot the operational issues. You can monitor the user's activities to have the full insight who's doing what in your AWS environment. Next, let's talk about AWS CloudWatch. AWS CloudWatch is a monitoring and logging service offered by AWS that provides real time and historical insight into the performance and health of your AWS resources, application, and services. It collects and processes the log files, metrics, and events to provide you with a unified view of your AWS environments and enable you to set the alarms and automate the actions based on the metrics and events. It can be used for operational monitoring, troubleshooting, and optimization of AWS resources and applications. There are different types of data that can be collected with CloudWatch. Metrics are data related to the performance and behavior of AWS resources such as CPU utilization, network traffic, and disk usage. Logs. Logs are events and messages generated by AWS resources and applications. Events. Events are data related to the changes and events that occur within your AWS resources and applications. CloudWatch record all this data for your applications and resources. CloudWatch brings lots of benefits for the users, and there are different use cases that supported by the CloudWatch, like performance monitoring. CloudWatch monitor the performance of your AWS resources and applications to identify and troubleshoot the issues. Resource optimization. You can identify the opportunities to optimize the resource utilization and reduce the cost. Security and compliance. You can easily detect and respond to the security events and ensure compliance with regulatory requirements. Application monitoring. You can monitor the health and availability of your applications running on the AWS infrastructure. Integration with other AWS services. CloudWatch can be integrated with a wide range of AWS services, including Amazon EC2, Amazon S3, AWS Lambda, and many other AWS services. You can use the AWS CloudWatch with any services that support the CloudWatch metrics and logs. Pricing. CloudWatch offers a free tier that includes basic monitoring and alarm functionality. Additional charges apply for more advanced monitoring features such as custom metrics and dashboards. AWS CloudWatch is a powerful monitoring service that enables you to collect, view, and analyze the metrics, logs, and events from the AWS resources and applications. CloudWatch is a powerful monitoring service that enables you to collect, view, and analyze the metrics, logs, and events from AWS resources and applications. By using CloudWatch, you can monitor the performance and behavior of your AWS resources and applications, troubleshoot the issues, optimize the resource utilizations, detect and respond to the security events, and ensure the compliance with regulatory requirements. We will demonstrate how to use the CloudWatch for monitoring the applications and resources in your AWS account. Next, let's talk about AWS management and governance services. AWS management and governance services are designed to help the organizations to manage their cloud resources and applications in a secure and compliant manner. These services provide a suite of tools and features that enables the administrators to automate the task, monitor the performance, track the cost, and enforce the policies. Here are some of the key AWS management and governance services. CloudTrail. This service enables you to log, continuously monitor, and retain the account activities about action taken within your AWS account. This is useful for auditing and compliance purpose as well as for the troubleshooting. CloudFormation. This service allows you to provision the AWS infrastructure resources in a repeatable and automated manner. You can use the pre-built templates or create your own templates to deploy the resources consistently and reliably. CloudWatch is a monitoring and logging service provided by AWS. It enables you to monitor the services and applications that run on the AWS. You can also monitor your on-prem resources using AWS CloudWatch. CloudWatch collects and track the metrics, monitors the log file, and set the alarms. System Manager. This service allows you to automate the operational tasks across your AWS resources, including patch management, application deployment, and instance configuration. Control Tower. Control Tower is a service provided by AWS that helps the organizations to set up and govern the secure and compliant multi account environment on AWS. AWS Control Tower makes it easier to manage the multiple AWS accounts and automate the account provisioning and configuration. AWS Config. This service provides a detailed inventory of your AWS resources, including configuration history and change notifications. It can also help you to identify the compliance issues and potential security threats. Identity and Access Management Service. This service provides the granular control over user access to AWS resources. You can create policies that define who can access specific resources and what actions they can take. In summary, AWS Management and Governance Services provides a comprehensive set of tools and features to help you manage your AWS resources and applications in a secure and compliant manner. We will discuss about these tools in more details in the coming slides. Next, let's talk about AWS System Manager. AWS System Manager provides a comprehensive set of tools to help you manage your infrastructure and applications more efficiently and securely. AWS System Manager provides a range of features including inventory management, patch management, run commands, state manager, maintenance windows, automation, and parameter store. AWS System Manager integrates with other AWS services to provide a comprehensive solutions for managing your AWS resources. AWS System Manager is a powerful service that enables you to manage your AWS resources and applications from a single place. By using AWS System Manager, you can simplify the operations, improve security, reduce cost, and increase agility. System Manager helps you in inventory management, collects the metadata about your AWS resources, software, and operating system. Patch management. System Manager helps you to automate the process of patching your EC2 instances, on-prem instances, and other supported AWS resources. Run command. System Manager enables you to remotely execute the commands on your instances, including Linux and Windows machines. State Manager. System Manager helps you to define and maintain the desired state of your instances. Maintenance window enables you to define a window of time for scheduled maintenance tasks such as patching and rebooting the instances. Automation and parameter store enables you to create and run the automation workflow that perform the common operational task. And parameter store enables you to securely store and manage the secrets, configuration data, and other frequently used parameters. System Manager brings lots of benefits for its users. System Manager helps you to simplify the operations. AWS System Manager provides a single interface for managing your AWS resources and applications. That makes it easier to automate the common operational tasks. Improve security. Parameter store enables you to securely store and manage the secrets, reducing the risk of unauthorized access. Reduce cost. Automation and patch management features can help you to reduce the time and effort required to maintain your instances, resulting in cost saving. Increase agility. By automating the common operational task, AWS System Manager can help you respond more quickly to changing business needs. System Manager integrate with other AWS services such as AWS Identity and Access Management, CloudFormation, and CloudTrail. Integration with AWS IAM enables you to control the access to System Manager features and resources. Integration with AWS CloudFormation enables you to automate the deployment of System Manager resources. Integration with CloudTrail provides detailed logging of System Manager API calls, helping you to meet the compliance requirements. So next, we are going to talk about another category of services called app integration services. And when we talk about the app integration services, we are really talking about three different types of services on AWS. AWS offers several services that enable the organizations to build and manage the integrations between different applications. We will discuss about some of the key AWS integration services. Imagine Simple Notification Service. Simple Notification Service or SNS is a fully managed pub/sub messaging service that enable you to send and receive the message between different services and applications. The publisher sends the message and subscriber receive the message. SNS supports fan out, filtering, and mobile push notifications and can be integrated with other AWS services such as Lambda, SQS, and Kinesis. Simple Queue Service or SQS is a fully managed messaging queue service that enables you to decouple and scale the microservices, distributed systems, and serverless applications. SQS provides durable message storage and batch processing capabilities. AWS Step Functions is a service that let you coordinate with components of distributed applications and microservices using visual workflows. These are just few examples of many application integration services provided by AWS. Depending on the need, these and other AWS services can be used to create a robust and scalable integration architecture. Let's talk about Simple Notification Service or SNS. SNS is a fully managed pub/sub messaging service that enables you to send and receive the messages between different services and applications. It provides reliable, scalable, and highly available messaging capabilities that can be used to decouple the application components, coordinate the workflows, and trigger the downstream actions. SNS supports multiple message delivery protocols, including HTTP and HTTPS, email, SMS, mobile push notification, and AWS Lambda. SNS allow you to publish the message to multiple subscribers or endpoints simultaneously using either a topic-based or direct publish model. SNS provide message filtering capabilities that allow the subscriber to receive only the messages that are relevant to them based on message attributes and filter policies. SNS supports message encryption in transit using HTTPS and message encryption at rest using AWS KMS. SNS can be integrated with other AWS services such as AWS Lambda, CloudFormation, CloudTrail, CloudWatch to provide the seamless messaging capabilities across the AWS environment. SNS provides detailed monitoring and logging capabilities through Amazon CloudWatch, enabling you to track the message deliveries, errors, and performance metrics. SNS is a fully managed messaging service that enables the distribution of messages to multiple recipients or subscribers. It can be used to send messages to a large number of subscribers, such as mobile devices or distributed system. The architecture of SNS involves the following components. Publisher. These are applications that send the messages to SNS. A publisher send a message to a SNS topic. Subscribers. These are applications that receive the message from the SNS. The message is delivered to all subscribers that are subscribed to the topic. SNS supports a variety of subscriptions type including email, SMS, HTTPS, AWS Lambda, and mobile push notifications. Additionally, SNS provides a feature called message filtering that enable the subscribers to receive only the messages that are relevant to them based on the filtering criteria. This helps the user to filter the messages that they want to receive. Topics are used to categorize the message and organize the subscribers. Publishers send message to topics and subscribers receive the message from the topic. Messages are the information that is exchanged between publishers and subscribers. They can be of any type, such as text or binary data. Each subscriber receives the message and process it. Amazon SNS is a powerful messaging service that provides a flexible and scalable way to send and receive the messages between different services and applications. Whether you need to coordinate workflows, trigger downstream actions, or deliver the real time notifications to your users, Amazon SNS can help you achieve your messaging goal with ease. Let's talk about Simple Queue Service or SQS. Amazon SQS is a fully managed message queuing service provided by AWS. It enables you to decouple and scale the microservices, distributed systems, and serverless applications. SQS allow you to send, store, and receive the messages between distributed application components without losing the message or requiring each components to be always available. SQS provides two types of message queues, standard queue and FIFO. Standard queue offers the best effort ordering, while FIFO guarantee that messages are processed exactly in the order they are sent. One of the main benefits of SQS is its ability to handle the large number of messages, even millions of messages per second, and it automatically scale with your application. It also provides a pay as you go pricing model, so you only pay for the number of messages you send and receive. SQS can also be used to distribute the workloads among multiple consumers. This way, you can process the messages in parallel and increase the overall performance of the application. It supports a decent amount of data. You can put about 256 KB into a message and it allows messages to be stored for up to 14 days. SQS is very beneficial for designing the application. A practical use case for Amazon SQS would be to decouple the components of a distributed application. For example, let's say you have a e-commerce application that processes the orders. The application could use the SQS to send the orders to a separate service for shipping and handling. This way, the order processing services doesn't have to wait for the shipping and handling service to complete. Another example would be to use the SQS as a buffer between a web application and a database. This way, the web application can send a message to SQS when a request is made to the database, and the database can process the request when it's ready. The architecture of the SQS involves the following component: message producer. These are the applications that send the message to SQS. A message producer send a message to an SQS queue. Message consumers. These are the applications that receive the message from the SQS queue. A message consumer polls the queue for the new messages. Queues are used to store the messages temporarily until they are processed by the consumer. When a message is retrieved, it is removed from the queue and processed by the consumer. Messages. Messages are the information that is exchanged between producer and consumer. They can be of any type, such as text, or binary data. If the consumer is unable to process the message, it can return the message to the queue for the processing at a later time. As we talked about that SQS provides two types of queues. Standard queue. These provides a highly scalable distributed queue that guarantees at least once delivery of a message. They can be used to decouple the components of an application or to handle high volume of messages. FIFO queue. This provides a first in, first out ordering of messages and exactly once processing. They can be used in scenarios where ordering and deduplication of messages are critical. Amazon SQS is a fully managed message queue service that enable the decoupling and scalability of distributed applications. Here are some of the key benefits of using the Amazon SQS. Scalability. Amazon SQS is a fully managed service, which means it automatically scales to handle an unlimited number of messages and message queues. You don't need to worry about capacity planning or scaling the infrastructure as the application grows. Reliability. Amazon SQS is designed to be highly available and fault tolerant. It replicates the messages across multiple availability zones to ensure that your messages are always available when you need them. Amazon SQS enable the decoupling of the components in your distributed application. This allows you to build the applications that are most resilient and fault tolerant. Flexibility. Amazon SQL supports multiple message formats, including JSON, XML, and binary data. This allows you to use the messaging service with a wide variety of applications and programming languages. Amazon SQS uses AWS identity and access management to control access to your message queues. You can also encrypt your message using AWS Key Management Service to add an extra layer of security. Amazon SQS is a cost effective solution for queuing the messages. You only pay for the message that you send and receive, and there are no upfront cost or minimum fee. Overall, Amazon SQS provides a reliable, scalable, and flexible messaging service that can help you to build the distributed applications with ease. Last but not least, let's talk about the AWS Step Function. AWS Step Function is a serverless workflow service that enables you to coordinate the components of your application into a series of steps or a state machine. You can use these step functions to automate the multi-step workflow such as data processing pipelines, order processing, and application orchestration. AWS Step Function is a powerful tool for building scalable and reliable application, and it can help you to streamline your workflow and reduce the complexity of your application. State machine visualization. AWS Step Function provide a visual representation of your state machine, which makes it easy to understand and debug the complex workflow. Step function is a fully managed service that makes it easy to coordinate the different steps of your application or service using the visual workflow. Built-in error handling. Step function automatically handles the error and retries the failed step, making your application more resilient and reliable. Step function provides built-in error handling, allow you to handle and retry errors, and also it allow you to track and visualize the progress of your workflow with the help of the CloudWatch. Integration with AWS services. You can integrate your workflow with a wide variety of AWS services, including Lambda, ECS, and SNS. Fine-grained IAM permissions. AWS Step Functions allow you to set fine-grained permissions for your workflow, giving you control over who can execute these specific steps in your state machine. Reusable workflow. Step functions also support the ability to call step functions from another step functions. This way, you can create a reusable workflow. Error handling. Step functions support the state timeouts, retry, and error handling. AWS Content Delivery Network and Services provides a range of services that helps business to deliver the content and data to their customers in a fast, secure, and reliable manner. This helps users around the world to view the same high quality content without slow loading times. Without a CDN, content origin server must respond to every single request. This results in significant traffic for the origin server and subsequent load, thereby that increases the chances of origin server failure if the traffic spikes are extremely high. Content delivery network and services solves this problem for the users. Once you host the application on the cloud, you would want the users get the better performance when they access the application. The goal of the CDN is to reduce the latency by reducing the physical distance that the user's request has to travel. CDN store a cached version of your website content in multiple geographical locations around the world, which are known as point of presence. These point of presence will contain their own caching servers and will be responsible for delivering that content in the user's location. Content and delivery services enable the customers to distribute and deliver the content and applications globally. The content and network delivery services include the multiple components like Amazon CloudFront. CloudFront securely delivers data, video, application, and APIs to customers with low latency and high transfer speed. Amazon Route 53. Route 53 is a highly available and scalable DNS service that translates the domain name to IP addresses. S3 Transfer Acceleration. S3 Transfer Acceleration is a data transfer service that uses CloudFronts as a location to accelerate the data transfer over the internet to Amazon S3. The transfer acceleration can be used if you are transferring large amount of data to S3 over internet. Direct Connect, a dedicated network connection from on-prem data center to AWS that enable customers to transfer large amount of data with low latency and high throughput. Global Accelerator, a service that routes the traffic to nearest AWS region for faster delivery of applications to end users. Elastic Load Balancing, automatically distribute the incoming application traffic across multiple EC2 instances, containers, and IP addresses in one or more availability zones. These services work together to provide a solution for delivering and distributing the content and applications globally. Let's talk about each of these services in detail. Next, let's talk about AWS CloudFront. CloudFront is a content delivery network service offered by AWS. A content delivery network or CDN is a network of servers that are distributed around the world and are used to store and deliver the content to users based on their geographic locations. When a user requests the content, CloudFront routes the request to the server that is closest to the user, ensuring that the content is delivered quickly and with the minimum latency. CloudFront works by caching the content at different locations known as locations around the world. When a user requests the content, CloudFront checks to see if the content is already available in the cache at the nearest as location. If the content is available, then the as location serve the content directly to the user. If the content is not available at the nearest as location, CloudFront retrieve the content from the origin server, such as Amazon S3 bucket or an EC2 instance, and store a copy of the content at the nearest as location in the cache memory for the future purpose. CloudFront can deliver both static and dynamic content. CloudFront provides advanced security features such as DDoS protection. CloudFront integrates with AWS Shield, a service that provides the DDoS protection for your content. Web Application Firewall or AWS WAF. Web Application Firewall integration. CloudFront can be integrated with AWS WAF, which allow you to create the rules to block the malicious traffic and protect your web applications from the common web exploits. CloudFront provides several benefits. Low latency. By routing the request to the nearest as location, CloudFront ensures that the content is delivered to users with minimal latency. High transfer speed. CloudFront uses a global network of servers to deliver the content, which can improve the transfer speed compared to delivering the content from a single location. CloudFront supports SSL and TLS encryption to protect the data in transit between the client and the origin server. Integration with other AWS services. CloudFront can be integrated with other AWS services such as Amazon S3, Amazon EC2, and Elastic Load Balancing. CloudFront offers a number of security features to protect the data and resources that are delivered through the services. Some of these security features include SSL and TLS encryption. CloudFront supports HTTPS and SSL TLS encryption to protect the transit data between the client and the origin server. Origin protection. CloudFront allow you to restrict the access to your origin server to only CloudFront IP addresses, which helps prevent the unauthorized access to your content. Custom SSL certificates. You can use your own SSL TLS certificate to secure the connections between CloudFront and your users. Signed URL and signed cookies. You can use the signed URL and signed cookies to restrict the access to specific content to only authorized users. DDoS protections. CloudFront integrate with AWS Shield. AWS Shield is a service that provides the DDoS protections for your content. Web application firewall integration. CloudFront can be integrated with AWS WAF, which allow you to create the rules to block the malicious traffic and protect your web applications from the common web exploits. Geo restrictions. CloudFront also allow you to restrict the access to your content based on the geographic locations. Access logs. CloudFront can store the access logs in S3 bucket, which can be used to track and analyze the user's traffic. CloudFront is a great service that helps to improve the performance and security for your web applications. A practical use case for Amazon CloudFront would be a company that runs a content heavy website, such as a news or media website, that needs to deliver the large amount of data and multimedia content to users across the globe. The company could use the CloudFront to distribute their content across a global network of edge locations. When a user requests the content from the website, CloudFront routes the request to the edge location that is closest to the user, which can help to reduce the time it takes to download the content. This improves the user experience, especially for users who are located far away from the origin server. The company could also use CloudFront to improve the security of their websites by using the features such as SSL TLS encryption to protect the data in transit. CloudFront can also be used to improve the performance of the website by caching the content at the edge locations. This means when a user requests the content that has already been requested by another user, CloudFront can serve the content from the edge location without having to retrieve it from the origin server. Company could use the CloudFront integration with other AWS services such as AWS WAF to protect the website from common web exploits and DDoS attack. Overall, CloudFront is a great solution to run the content-heavy websites where we need to deliver the large amount of data and multimedia content to users while improving the performance and security of the website. Next, let's talk about AWS Global Accelerator. AWS Global Accelerator is a networking service that routes the traffic over the AWS network to improve the availability and the performance of your applications. AWS Global Accelerator is a networking service that sends the users traffic through AWS Global Network Infrastructure. Improve your users' performance up to 60%. Global Accelerator utilizes the IP address and edge locations to route the traffic and uses the IP resolution instead of the DNS. So once the user reaches the edge location, no matter where you are resolving it to, it's going to route the traffic through AWS network and not the public internet. It can route the request to many different AWS resources, and that includes things like network load balancer, application load balancer, EC2 instances, or an elastic IP addresses. Now let's see how AWS Global Accelerator work. AWS Global Accelerator works by directing the traffic to the optimal AWS region. It does this by using the AWS Global Network, which is the network of point of presence located in various regions around the world. When a user requests to access an application, the request is first directed to the nearest AWS Global Accelerator endpoint. The endpoint then uses the AWS Global Network to determine the optimal AWS region for the user based on factors such as geographic locations, application health, and network congestion. Once the optimal AWS region is determined, the endpoint directs the user's traffic to that region. This can help to improve the application performance, reduce latency, and increase availability for users around the world. AWS Global Accelerator also provides static IP addresses called Accelerator IP that can act as a fixed entry point to the applications hosted in one or more AWS regions. Additionally, it also allows you to configure the health check for each endpoint so it can automatically fail over to healthy endpoint in case of any issues. AWS Global Accelerator can be used to improve the availability and performance of variety of applications including web applications, mobile app and APIs. Now, you might be wondering what is the difference between CloudFront and Global Accelerator as both are used to improve the application's performance. So let's talk about the difference between Global Accelerator and the CloudFront. AWS Global Accelerator and Amazon CloudFront, both services are offered by AWS, but they serve the different purposes. AWS Global Accelerator is a service that improves the availability and performance of the applications by routing the traffic to the optimal AWS region for a given user. It uses the AWS Global Network to direct the traffic to the optimal AWS region based on factors such as geographical locations, application health, and network congestions. It can improve the application performance, reduce latency, and increase the availability for users around the world. Amazon CloudFront is a content delivery network that speeds up the delivery of a static and dynamic web contents to user. It uses a global network of edge locations to cache the content and deliver it to the users from the edge locations that is closest to them. This can help to reduce the latency and improve the performance of web-based applications for users around the world. In summary, AWS Global Accelerator route the traffic to the optimal AWS region for a given user, while CloudFront speed up the delivery of the contents to the user. They both can be used to improve the application performance, reduce latency, and increase the availability, but are intended for different types of traffic and different use cases. Next, let's talk about Internet Gateway. AWS Internet Gateway provide a simple and secure way to allow the communication between instances in your VPC and the Internet. Internet Gateway is a horizontally scalable, redundant, and highly available VPC component. Internet Gateway serves as a bridge between your Amazon VPC and the Internet. It enables the communication between your instances and Internet. Internet gateway must be attached to a VPC in order to function. A VPC can only have one internet gateway attached at a time. The internet gateway is referenced in the VPC route table to allow the traffic to flow to and from the internet. Instances in a VPC with an internet gateway attached must have a public IP address in order to communicate with the internet. Internet gateway is a core component of any VPC architecture that requires the secure and reliable connectivity to the public internet. There are a few key points about Internet Gateway. Connectivity. Internet Gateway provides the connectivity between your VPC and the Internet. It enables the traffic to flow between public IP addresses assigned to your VPC and the public Internet. Scalability. AWS Internet Gateway is horizontally scaled, meaning it can handle a high volume of traffic and is designed to automatically scale as your network traffic increases. Redundancy. AWS Internet Gateway is redundant, which means if one gateway fails, another can take over without any disruption to your network traffic. Security. AWS Internet Gateway is stateful gateway, which means it tracks the state of the network connection between the VPC and the internet. This allows it to enforce the security policies such as allow or block the traffic based on specific criteria. Configuration. You can configure your AWS Internet Gateway to route the traffic to specific destinations such as other AWS services, on-prem resources, or internet. Cost. Internet gateway pricing is based on the amount of data transferred over the gateway. There is no upfront cost and you only pay for what you use. You can use the internet gateway to provide the internet services in your VPC. You can use the internet gateway with net instance or net gateway. That totally depend on your application architecture or business requirements. When you host the application on AWS, you will always want that your application is always available. Elastic load balancing is a service that automatically distributes the incoming web traffic across multiple EC2 instances to ensure that your application is always available and can handle a large number of requests. When a user requests to access your application, ELB or elastic load balancing will automatically route the request to one of the available instances, ensuring that the load is distributed evenly and no single instance become overloaded. It also checks the health of the instance before distributing the load and automatically route the traffic away from the instances that is not healthy. There are two types of elastic load balancer. Application load balancer. Application load balancer actually route the traffic based on HTTP and HTTPS. Network load balancer. Network load balancer route the TCP and UDP traffic. Next, let's talk about the application load balancer. Application load balancer automatically distribute the incoming web traffic across multiple EC2 instances. It routes the traffic based on HTTP and HTTPS. Application load balancer can route the incoming traffic based on the content of the request. This is accomplished by using the routing rules that match the URL path, host header, or other request attributes to a specific target group. This allows more fine-grained control over how traffic is distributed to your instances, making it possible to route the request to different parts of your application based on the URL path or other request attributes. Application load balancer allow you to offload SSL and TLS decryption from your instances and handle it at the load balancer. Application load balancer allow you to configure multiple listeners on different port and protocols. Next, let's talk about the network load balancer. Unlike application load balancer, which routes the traffic based on the content of the request, network load balancer route the traffic based on the IP protocol data. Network load balancer is used to route the TCP and UDP traffic to multiple EC2 instances, and it can handle millions of requests per second while maintaining the ultra low latencies. Network load balancer allow you to maintain the client connections to a specific instances even if the instance become unavailable. Network load balancer allow you to configure multiple listeners on different ports and protocols. Network load balancer has the following benefits. High performance. Network load balancer is capable of handling the millions of requests per second while maintaining the low latency. Connection persistence. Network load balancer allow you to maintain the client connection to specific instances even if the instance become unavailable. Sticky sessions. Network load balancer allow you to maintain the client connections to specific instances even if the instance become unavailable. Health check. Network load balancer can check the health of the instances and automatically route the traffic away from any instance that are not healthy. Multiple listeners. Network load balancer allow you to configure multiple listeners on different ports and protocols. Scale horizontally. Network load balancer can automatically scale to handle large amount of traffic by distributing it across multiple instances. So you can choose any load balancing method. You can choose network load balancer or application load balancer based on your architecture or your application requirement. Next, let's talk about AWS Route 53. Route 53 is a domain name system service offered by AWS. It's a global service. That means any change that you make are applied globally. Route 53 leverages the AWS as locations. Route 53 is a DNS service offered by AWS. It's a global service. That means any changes that you make are applied globally. Route 53 offers several advanced features such as health check, failover, and latency based routing to ensure high availability and optimal performance of your applications. Route 53 integrates seamlessly with other AWS services such as S3, Elastic Load Balancing, and AWS Certificate Manager to provide a complete solution for your applications need. Route 53 provides a simple console to manage the DNS records, and it integrates seamlessly with other AWS services to provide a complete solution for your application's need. AWS Route 53 offers these several benefits compared to the traditional DNS system. Scalability. Route 53 is designed to handle millions of requests per second and can scale automatically to handle the traffic spikes and DDoS attacks. Route 53 is a globally distributed service with multiple points of presence that ensure the reliable and fast routing of applications. Performance. Route 53 offers advanced routing policies that enable you to route the traffic to the nearest AWS regions, minimize the latency, and improve the end user's experience. Route 53 offers pay as you go pricing with no upfront cost or minimal fees, and you only pay for what you use. Amazon Route 53 is a highly available, scalable, and cost effective DNS service that can help you to route the traffic to your applications. Route 53 provides a complete solution for your DNS needs with advanced features such as health check, failover, and latency based routing. Scaling on AWS refers to the process of increasing or decreasing the resources such as EC2 or RDS instances. Scaling is one of the key services that helps you to handle the virtually unlimited load and request on your cloud hosted applications. Scaling automatically increase or decrease the resources as and when required for your application performance. There are two main types of scaling on AWS. Vertical scaling. This type of scaling involves increasing or decreasing the size of a single resource, such as increasing the amount of memory or CPU of an EC2 instance. This is also known as scaling up or scaling down. Horizontal scaling. This type of scaling involves the adding or removing the resources, such as adding or removing the EC2 instance to increase or decrease the capacity. This is also known as scaling out or scaling in. There are multiple services on AWS that helps you to scale the resources as and when required for your application performance. Auto scaling. Auto scaling automatically increase or decrease the number of resources based on predefined policies. Elastic load balancing. Elastic load balancing automatically distribute the incoming traffic across multiple resources to ensure that no single resource become overloaded. Vision CloudWatch. CloudWatch monitor the resource utilization and automatically trigger the scaling actions based on the predefined policies. Elastic Beanstalk. Elastic Beanstalk is a platform as a service that automatically handles the scaling and deployment of the applications. AWS Lambda. Lambda automatically scales to handle the incoming request. You can use any of these scaling services on AWS to handle the unlimited load for your cloud hosted applications. The scaling service you will use depend on your application architecture and business requirement. Next, let's talk about the security groups. Security groups are like virtual firewall that control the incoming and outgoing network traffic to an EC2 instance. AWS security groups are like stateful firewall, meaning once a connection is established, the response traffic is automatically allowed, regardless of any rules. Security groups have separate inbound and outbound rules that define the traffic that is allowed to flow into and out of an instance. Rules can be specified for specific IP addresses, range of IP addresses, or the security group, and the rules can be based on protocols such as TCP, UDP, or ICMP and on port numbers. Every EC2 instance is automatically associated with the default security group. It's recommended to create a custom security group with more restrictive rules. An EC2 instance can be associated with multiple security groups, allow you to apply multiple set of rules to the same instance. Security group rules can be modified at any time, allow you to change the level of access to your instances as needed. AWS also provide tools and services for auditing and logging the security group activity, such as Amazon CloudWatch logs and CloudTrails. Let's talk about virtual private cloud. AWS Virtual Private Cloud provides an isolated and secure network environment for your applications and data in the cloud. Virtual private cloud is one of the core components to host the applications on the AWS environment. Amazon Virtual Private Cloud is a service that allow you to create a virtual network in the AWS cloud. VPC support both IPv4 and IPv6 address types. With VPC, you can launch your own EC2 instances in a virtual network. You can assign your custom IP ranges to your network and configure the security and access control on your VPC. VPC allow you to customize your network settings such as IP address range, subnet, route table, network gateways. VPC allow you to create a secure, isolated environment within AWS cloud and still allow you to access the internet and other resources within the cloud environment. VPC allow both private and public subnets. So if you want to have some applications that can't communicate or can't be reached over the internet, or if you want to have some applications that are accessible from the internet, you can do both. If you have servers in private subnet that need internet access, you can use the network address translation or NAT function. for those private subnets. And there are multiple ways that you can actually establish a connection to your data center. You can create the multiple VPCs and connect the VPCs to each other with pairing connections, or you can use the transit gateway to enable the communication between multiple VPCs. There are multiple core components in a VPC that helps you to create the private network in the AWS cloud. Subnets. VPC is divided into one or more subnets. You can launch the resources such as EC2 instances into a subnet. Network address translation. VPC enable the instances in a private subnet to connect to the internet or other AWS services using NAT services. Security group. A security group acts as a virtual firewall for your instance to control the inbound and outbound traffic. Internet gateway. An internet gateway is a VPC component that allows the communication between instances in your VPC and the internet. Virtual private network. A VPN connection or a virtual private network can be established between your VPC and your data center that allow you to secure the communication between the two networks. Elastic IP addresses. An elastic IP address is a static IP address designed for dynamic cloud computing. You can assign the same elastic IP address to an instance in case of an instance failure. VPC peering. VPC peering enable you to connect two VPCs together to allow the communication between instances in the connected VPCs. VPC flow logs enable you to capture the information about the IP traffic going to and from your VPCs. We will talk about these core components in more detail in the coming slides. So first, let's talk about subnet. A subnet is a range of IP addresses within a VPC that allow you to group the instances based on security and operational requirement. The subnet must be associated with a VPC. You can associate a subnet with a single VPC, but a VPC can have multiple subnets. Subnets are of two types: private subnet. Private subnet can't communicate to the internet. Public subnet. Public subnet can communicate to the internet. A subnet can be associated with a route table, which controls the traffic routing for the subnet. You can create the subnet in one or more availability zones, providing high availability and failover capabilities of the applications hosted within that subnet. Next, let's talk about virtual private network. Virtual private network or VPN service allow you to connect your on-prem network to your Amazon VPC over an IPsec VPN connection. This allow you to securely access the resources in your VPC as if they were on your local network, providing a secure and reliable connection between your on-prem network and your VPC. VPN services uses the IPsec protocol to securely connect your on-prem network to your virtual private network in the cloud and has two core components. Virtual private gateway. Virtual private gateway is created in your VPC and serves as the target of your VPN connection. The VPC acts as a bridge between your VPC and your on-prem network. Customer gateway. Customer gateway is created on your on-prem network and is the source of the VPN connection. The customer gateway from on-prem establishes the IPsec VPN connection to the virtual private gateway in the AWS cloud and form the IPsec VPN connection to provide the secure connectivity. Once you establish the IPsec VPN connection, then you can enable the routing. You can update your VPC route table to allow the traffic to flow between your on-prem network and your VPC over the VPN connection. Scalability. You can create the multiple VPN connection to your VPC to provide the redundancy and increase the overall capacity of your VPN connection. IPsec VPN is the most common method to provide the secure connectivity between on-prem and AWS cloud. Next, let's talk about network address translation. Network address translation or NAT is used to enable the instances in a private subnet to connect to the internet or other AWS services. There are two types of NAT services offered by AWS. NAT gateway. NAT gateway allow the instances in a private subnet to access the internet hosted applications or other AWS services. While you cannot initiate the connection for those instances from the internet, NAT gateway is a highly available and managed network address translation service. AWS NAT Gateway is a fully managed service that automatically scales to handle the large amount of traffic that makes it suitable for use in an environment with high level of traffic. NAT instance. A NAT instance is a virtual machine in a public subnet of a Amazon VPC that allow the instances in a private subnet to access the internet while preventing the internet from initiating a connection with those instances. A NAT instance is a virtual machine in a public subnet of a Amazon VPC that allow the instances in a private subnet to access the internet or other AWS hosted applications. The NAT instance act as a proxy for outbound internet traffic from instances in the private subnet. When an instance in the private subnet send a request to access the internet, the request is forwarded to the NAT instance, which then send the request to the internet on behalf of the instance. When the response is received, the NAT instance forward it back to the requesting instance in the private subnet. NAT gateway and NAT instance both allow the applications hosted in the AWS private subnet to access the internet and internet hosted applications. But there are certain differences between NAT gateway and NAT instances. So let's talk about that. Management. NAT gateway is a fully managed service provided by AWS, while a NAT instance is a virtual machine that is managed by yourself. Scalability. NAT gateway automatically scale to handle the large amount of traffic, while a NAT instance can become a bottleneck as the traffic increases. NAT gateway provides better performance than a NAT instance due to its ability to automatically scale. Monitoring and logging. NAT gateway provides monitoring and logging through Amazon CloudWatch metrics and CloudTrail logs, while a NAT instance require a manual setup and configuration. High availability. NAT gateway provide automatic failover in the event of an instance or a availability zone failure, while a NAT instance require a manual failover setup and configuration. Cost. NAT gateway has a predictable and low hourly cost, while the cost of a NAT instance depend on the instance size and uses. Now in this module, we will talk about different storage services offered by AWS. Amazon Web Service offer multiple file storage services such as Amazon S3. It's a highly scalable, secure, and durable object storage service that allow you to store and retrieve the data from anywhere on the web. It is designed to store and retrieve any amount of data from anywhere on the web. Amazon EFS or Elastic File System. It is fully managed, highly scalable, and elastic file storage service that provides shared file storage for Amazon EC2 instances. It is designed to support a wide range of workload and applications, including big data analytics, media processing, and content management. Amazon FSx. It's a fully managed file storage service that provide highly scalable file systems that are accessible over the SMB and Lustre protocol. It is designed to support a wide range of workloads and applications, including Windows-based application, high-performance computing, and machine learning. Amazon Storage Gateway. It is a hybrid storage service that enable you to securely store and retrieve data from AWS cloud storage and to connect your on-prem applications with the AWS cloud. It provides a virtual tape library, file gateway, and volume gateway to support a wide range of storage scenarios. Each of these file storage service offers unique features and benefits and can be used for a wide range of workloads and applications. We will talk about these services in detail. Next, let's talk about S3 or Simple Storage Service. Simple Storage Service is a cloud-based object storage service provided by AWS. It allows the users to store and retrieve the data in the form of objects. First, let's understand what is object storage. Object storage is a type of data storage architecture that manages the data as object instead of a block or files. In object storage, each object consists of a data, metadata, and unique identifier. The data can be of any type such as documents, images, videos, or audio files. The unique identifier is used to locate and retrieve the object from the storage system. Object storage is highly scalable and designed to handle massive amount of unstructured data. Object storage in Amazon S3 is a type of data storage that store data as individual object rather than as a file hierarchy or block device. Each object is identified by a unique key and can contain data, metadata, and various access control information. The objects are stored in a flat namespace, meaning that there are no hierarchical relationship between objects, unlike traditional file system. Object storage in S3 is designed to scale horizontally, meaning that it can store an effectively unlimited amount of data by adding more storage nodes to a cluster. This makes it a well suited for storing large amount of unstructured data such as photos, videos, and backup. Object storage system also typically provide features such as versioning, which allow the users to store multiple versions of an object and roll back to a previous version if necessary. S3 provides a simple web service interface that can be used to store and retrieve any amount of data at any time from anywhere on the web. S3 stores the data redundantly across multiple devices in multiple facilities. S3 is highly durable and reliable storage solution for a wide range of use cases, including backup and archival, big data analytics, and disaster recovery. Amazon S3 at a high level lets you store files as object inside of a bucket. Now, bucket are the unit of the organization within S3. You will create a bucket. It will have a set of settings, and then any file that you drop in the bucket can have those settings applied to it. It allows you to store the data automatically across multiple availability zones, which give you the durability and resiliency for your data. Now, another great feature of S3 is that it enables you to have URL access of your files. So if you want to send a link to someone else to access the file within your S3, assuming the permissions are correct, you can actually do that. And it also offers the configurable rule for data lifecycle. So if you want something to expire after a period of time or go to some different storage class, you can do that. It can also serve as a static web host, and we will actually be implementing that later within this module. When you store a object in S3, you can choose the different storage options based on your data accessibility and application architecture. So first of all, we have S3 standard, and by default, if you upload a file to S3, it will have the S3 standard storage class. Then we have the S3 intelligent tiering. And this is the special storage class that will allow you to move your data to a correct storage class based on uses. Then we have S3 standard infrequent access. So if you have data that is not frequently accessed, you can get a lower cost by utilizing this particular storage class. Now it still has the standard resiliency because it leverages the multiple availability zone. But we also have S3 one zone infrequent access, and this is for data that is not frequently accessed, but it is only stored within one availability zone. So you get a much lower cost with this storage class compared to other options. However, you do have a less resiliency. Glacier for long-term archival data that may be retrieved in several hours or even days. Glacier Deep Archive for the lowest cost archival storage with retrieval times of 12 hours or more. Let's talk about these S3 storage classes in more detail. So let's talk about the intelligent tiering first. Intelligent tiering is the only way that you can automatically move the data to the most cost effective storage tier based on access. It has two access tiers. Frequent access tier, this tier store the object that are frequently accessed. Infrequent access tier, this tier store the object that are infrequently accessed. The storage class automatically move the object between the two access tiers based on the access patterns and charges a low per object monitoring and automation fee. This makes it a cost effective for data with unknown or changing access pattern. This storage class is useful for customers with data that has unknown or changing access patterns and need a cost effective storage solution. The data stored in intelligent tiering storage class can be retrieved quickly and easily, and it can be transitioned to other S3 storage classes in the future if required. Next, let's talk about the S3 lifecycle policies. Amazon S3 lifecycle policies are used to automatically move the objects between different storage classes or to archive or delete the objects. Lifecycle policies consist of a set of rules that are applied to an object in a specific S3 bucket. Each rule has an action and a transition or an expiration date. For example, a rule might transition a object to the Amazon S3 standard infrequent access storage class 30 days after they are created, and then archive them to Amazon S3 Glacier storage class after 90 days. You can use the lifecycle policies to transition objects to different storage classes. For example, moving data from S3 standard storage to S3 infrequent storage after 30 days. Archive the objects to Amazon Glacier S3. For example, moving data that has not been accessed for 60 days to Amazon S3 Glacier. Permanently delete objects. For example, deleting data that hasn't been accessed for 1 year. You can also set up different rules for different prefixes or object tags so that you can target specific groups of objects within a bucket. You can also create multiple policies for a single bucket, allow you to set different rules for different subset of objects. Lifecycle policies can help you save money on storage cost by automatically moving the data to lower storage class, and can also help you comply with the data retention and archival regulations by automatically deleting or archiving data after a certain period of time. Next, let's talk about the AWS S3 transfer acceleration. S3 transfer acceleration works by routing the traffic over Amazon's optimized network path, and it does it by utilizing the AWS as locations as part of the Amazon CloudFront, which minimizes the distance data need to travel over the internet. This reduces the latency and increases the transfer speed, especially for users who are located far away from the S3 bucket. To use the S3 transfer acceleration, you simply need to enable it on the S3 bucket that you want to use it for. You can then use a special endpoint provided by AWS to upload or download the data from the bucket. It works by using the CloudFront as locations as acceleration endpoint that can upload or download the data to and from the Amazon S3 at a faster speed than a direct connection to the S3 service. This can be particularly useful for users who need to transfer the large file over long distances, such as between different regions or continents. It is worth noting that S3 transfer acceleration may not be beneficial for all use cases. For example, if you are transferring data within the same AWS region over a high speed private network, you may not see any significant speed improvement. However, if you are transferring the data over long distances over the public internet, S3 transfer acceleration can be a useful tool to improve the data transfer speed.